Hello, I'm Svetlin Nakul from SoftUni, the software university. I'm an experienced tech trainer who helped more than 100,000 young people to begin coding, learn software development, and start a tech job. Just Google my name and you'll find more about me, my programming books, software academies, conference talks, and other teaching activities. Today, I'm happy to welcome you to my free Java Coding Basics course for absolute beginners in computer programming. This course is designed for beginners who want to start with Java coding and find out if they like it. It covers the first steps in programming: installing the Java development tools and development environment, writing commands and simple programs in Java, receiving input from the user and printing text and numbers to the user, using data, operators, expressions to perform calculations, using if-else and switch case conditional statements, repeating blocks of codes, using loops, for loops, while loops, and do while loops, as well as writing more complex control flow logic, which combines loops, conditional statements, nested loops, and nested conditions. This course is just a start in Java programming. To become a software engineer and start a tech job, you should learn and practice programming 10 to 15 times more than what I give you in this course. It takes time and effort to build the skills for your first IT job, so be patient and keep coding for a long time. This course teaches skills, not just theory. Each course sections comes with carefully prepared hands-on practical exercises where you write code to solve practical problems, run and test your solutions, maybe make bugs, fix them, and test your code over and over until it finally works properly. The entire course provides more than 70 exercises with automatic grading in the SoftUni judge system. Remember that coding is a skill and it should be practice, just like any other skill. Write code to learn the skill of coding. To check your solutions of the practical hands-on exercises from this course, I give you free access to the SoftUni automated judge system where you send your code and you get an automated grading. The judge tells you whether your solution is correct or wrong. This is quite useful. Try it and you will love it. During the course lessons, I will show you how to solve several coding problems. Follow my guidelines and sample solutions, which I show you, and write your own solutions. Try to solve the additional exercise problems as well. Write code, play with the code, experiment, make bugs and imperfections, fix them, write code, do it many times. This is how you acquire coding skills. Don't skip the coding exercises at the end of each course section. They are much more important than the video lessons. This gives you the practical skills, the skills needed for your next tech job. If you are serious about programming, take this course with all its exercises. You should invest about 30 or maybe 40 hours. Yes, this is a lot of time, but learning programming takes time. Just like learning math. Did you remember how many hours you spent at school to learn the basics of math? In case you have a question or difficulty solving some of the exercise problems, or you have a bug and you don't know how to fix it, we are here to help. Join the SoftUni community at softuni.org and ask for free help from our mentors. Yes, you can ask anything about this training and about programming and you get a free answer. At SoftUni, we already helped hundreds of thousands of students to learn coding. See their profiles at SoftUni alumni at LinkedIn. Just check and you'll see. Let's jump into Java coding now! At the start of our free Basics Java Coding course, I want to review the course content. I will explain you what shall we learn, what will be the topics, and I will mention the practical coding assignments which will serve as homework. So we'll start with our first topic, which is about Java coding. Our first steps in Java. I will introduce the Java language, the integrated development environments, the concept of compiler, Java platform, Java virtual machine, Java runtime, and I'll show you how to write simple commands in Java and how to write simple Java programs, how to compile, run, and execute them, how to test the output results, and also I'll give you some hints how to avoid certain typical bugs when you write Java code. We'll write simple Java classes with public static void main, with system out println, programs like hello world and similar things. You have a practical homework at the end of this first topic, because learning by doing is the most important concept that you should follow when you learn coding. The next topic will be about expressions, statements, variables, data types, calculations, operators and expressions, and how we make calculations in Java, how we combine data with some expressions to perform some calculation, and I will explain in this second topic how you get data from the user, the so-called standard input, how you read the standard input or the so-called console, and how you print data on the standard output on the so-called console. So I will introduce the JavaEQ scanner class, and also will show you how to read text and numbers and how to print formatted output to the console. Of course, you have practical coding assignments which will serve as your homework. The next topic is about conditional statements in Java. I will show you how to define control flow logic in Java using the classical if-else conditional statement, which works like this. If some condition is true, then you should execute this block of code. Otherwise, you execute another different block of code. Using these conditional statements, you can create program logic which splits the execution on different paths depending on the input data. In the next topic, I will go further and I will introduce some advanced conditional statements, such as more complex conditions based on the logical or, logical and logical not, also with brackets, and I will show you how you can nest if statements inside other if statements. So if inside another if else inside another if else. Using this technique, we can build more complex programs, and we can check more complex conditions and series of conditions. We'll see how, and of course you have homework assignments related to what we have learned in this topic, because learning is done by doing. To learn coding, you need to code, to practice. In the next topic, we'll learn how to repeat blocks of code, how to execute many times certain lines of code. For example, how we can increase the value of certain variable from x to y, for example, from 1 to 100, and have in certain variable 1, 2, 3, 4, 5 until 100. And how we can print, for example, this variable inside the body of this for loop. For loops are one of the most simple ways to repeat blocks of code, and this happens often in the real world. For example, if you want to climb the stairs in your house, you repeat many times step ahead, step ahead, step ahead, step ahead, many times. So this is a loop. In this topic, as usually, we'll have a homework assignments where we will write for loops and we'll solve practical problems and we'll submit them for automatic grading in the Softuni Judge. The next topic will be about for loops, which is even more simple than for loops, and they are constructions in Java which allow us repeating blocks of code while certain condition is true. For example, while a is less than 5, do the following: increase the value of a and print the value of a. And this is called while loop. While loops are quite simple and I will demonstrate them. We'll solve several practical problems using while loops, and you'll have homework as well. Finally, the most complex and the most interesting topic for me is the topic about the nested loops, where we'll learn how to write more complex control flow logic in our Java programs. Using loops and combining them with conditions, also nested loops with nested conditions, we can achieve more complex logic and we can solve more complex real-world problems. So what's inside, what's the concept of nested loop is just a simple loop staying inside of another loop. For example, if we have a building and it has floors and at each floor we have many rooms, we can iterate with a single loop through the floors and with the nested loops through the rooms inside certain floor. So this is an example from the real world where we'll need nested loops. Again, we'll have several coding exercises which you'll have as homework assignment. So in the entire course, you have more than 70 coding exercises which you can submit for automated evaluation. And please don't skip them, because learning coding can only be done by coding. If you just watch videos, you will learn nothing. You will just have fun. But if you write the code, if you write the exercises, if you make mistakes, fix them, think how to solve this, how to overcome this mistake, you will learn and you will get skills. So let's go ahead with the next topic from this lesson. Before starting with the first section of our free Java Basics course, I want to show you the judge system. The judge system is something very helpful. It's an automated online website where you send your code after you solve certain problem, and the judge system tells you whether your code is correct or wrong. And when it's wrong, you can click details and you can learn where exactly your mistake is. So the judge system allows you sending your solutions for certain problems for automated evaluation, and you get a score from the system instantly. Let's see how this works in action. For our Java Coding Basics course, your online judge system will be at this address: https://judge.softuni.org/contests/3273. Let's open this and see the judge system in action. So this is the Java Basics full course. It consists of problems. In our case, each context has many problems. In our case, we have 74 problems, which is a good amount of exercises, and you should solve all of them if you want to learn coding, because coding is learned by practice. So you click the practice button and it will open all these exercises, and you choose some of them. For example, this fourth calculations, and you paste your code. Let me see whether I have something in my clipboard, and you click submit, and after that the system tells you that it's not processed, so you click refresh because it runs asynchronously, and it says your code is correct. If you put wrong code, let me see what shall you achieve. You click submit, your code is not correct, so you click here and it says, oh, incorrect code. I click details and the system will tell me where is the problem, and it says 1, 2 is different. This is the third one because they start from 0. So you should have 6 as output for the last expression, but your output is 80. So your code looks like it's incorrect. So this is how the judge system works, and it's quite useful. This is the first screen where you see your contests and you choose a problem. You put your solution, you copy this from IntelliJ IDEA, from your code editor, and you submit, and you click this refresh button here, and you wait a bit. It usually happens instantly, and you get an answer whether your solution is correct or wrong. This is very, very, very helpful, because when you solve problems, you don't need a mentor or someone to tell you whether you are doing the things correctly or wrong. You just send your code and it tells you immediately. So please use it. Please use the judge system, because learning coding is only possible by coding. Please make your exercises. Otherwise, you will just have fun watching the videos and you will learn nothing. Good luck, and go ahead now with the first section from our Java coding course. This section is the beginning of our journey with Java coding. In this section, I will explain you what Java is, the Java programming language, the Java platform, the Java runtime environment, what a compiler is, what an IDE, integrated development environment is, and how to write simple Java programs in IntelliJ IDEA, our IDE. And I will demonstrate you how to write, compile, and run Java programs with several code examples. As a homework assignment, you have a few hands-on exercises which are about writing a few simple Java programs, such as what I demonstrated to you in this section, and submitting your solutions to the judge system for evaluation. Let's start. So, welcome to coding. Coding is about writing and running programs, and for this session and for this entire training course, we'll use the Java programming languages, so we'll write Java programs. Coding means to give commands to tell the computer what to do. It's something like, please do this, please do this, please do this. We already know this because we already use many machines in our everyday living. For example, we give commands to the TV through the remote control. We say, please switch to the first channel, or please increase the volume, or things like that. So in programming, we write commands as a text, as a sequence of characters, like the shown on the screen. System.out.println in brackets and in quotes, I'm coding, finishing with semicolon. This is an example of Java command, a command written in the programming language Java. Computer program is a sequence of similar commands like the above. For example, this is a computer program which consists of 3 commands: the first command, the second command, and the third command. This program just brings 3 lines of code, this 3 lines of text, this and the third. So commands are something which tells the computer to do some action, and programs are sequences of commands which together solve more complex program. Okay, so let's go ahead with this. Commands in Java will be something that we'll write every day. And this is another example, a command which calculates an expression, this expression, 5 added to 5. And this is a command to print, to calculate the expression and print its value. This is another program which checks if certain word contains another word. It checks whether the string soft_uni contains the string uni, and this will return true because it's true. This is another sequence of commands, another program which iterates from 1 to 100 and prints the value of I. I want to demonstrate you all of this. In order to do that, I will start a program called IntelliJ IDEA, this one, IntelliJ IDEA Community Edition, and I will write the commands inside it. I have already prepared project in which I can write these commands, and later I will show you how to install Java and how to install IntelliJ IDEA. But let's see what happens with the starting of IDEA. Looks like it's incredibly slow. Maybe some updates is going on or something else, but it will start sooner or later. Okay, looks like it will start soon, so I need to wait. Java is sometimes slow, sometimes not, especially when it starts, but that's life. If you are a developer, you will need to wait sometimes for technical reasons like this. Okay, so I wanted to show you a simple command and how we can execute it. Oh, it's really incredibly slow. My computer is not slow, but maybe something is updated, or I'm not sure what happens, but finally it started. So let's give an example. Print hello, and we can run this just by saying run this main class. We have a program, and this program consists of some declarations like these ones and some commands. The commands are given here. We cannot just give directly commands. We should put these commands in a class and in a method, which we will learn about later. But we can print several commands. System.out.println, of example, another message. I can print one message, which is hello, and another message, which is another message. When I run this, the program is compiled and run, and it prints these two lines of strings. Okay, I can also print system.out.println, for example, 5 plus 5, which is an example of calculating an expression and printing it. I will run this. It needs some time to be built, and this is the output from our program. So I represented this example and this example, and I didn't give you this, but there is a shortcut sout. When we print it, when we type it, it transforms to system.out.println, and I will check whether soft_uni dot contains uni, and it will give me true. It's true. It's correct that this contains this. We'll learn about these commands later, but first let's catch the idea. We have this IntelliJ IDEA, which is a program for writing Java programs. This is a Java program. These are the commands of this Java program. Okay, and these are some additional things that we need to put in order to run these commands, just like a preparation. Okay, so let's go ahead and I will explain you many other things about Java programming. But first, let's see this example. This is called for loop. This is a command which says please repeat for int I starting from 1 until I is less than or equal to 20, increment I and print I. So this will print the numbers from 1 to 20. I'll show you. Run main. Okay, so this really prints the number from 1 to 20. So this is a command which consists of repeat command holding inside it print command. So we use system, which says the system, the system class dot out, which means the output, this window. It has in and out, and println means print a line, print a new line holding something, holding hello, for example, print another message, etc, etc, etc. So we have commands in the Java language as well as in any other language, and these commands perform some action. We say please do something. It's something like object dot another object, or just object dot do something. For example, it might be printer dot print a line, or printer dot new page, or email dot send, and here we can give the subject, the email body, etc. Or it should be tv dot start, or maybe the coffee machine dot make coffee, and in brackets we say that it should be short coffee or long coffee or something like this. Okay, let's go ahead with some other concepts. Programming in computers means writing computer programs. This is an example of computer program, which is very small. Big programs like Microsoft Word hold hundreds of thousands of lines of code, not just 5 or 10 or 20, because they are more complex. But programming means writing computer programs which are sequences of commands. We use certain programming language such as Java or Python or C++ or JavaScript, and we often implement some algorithm. Algorithm is a sequence of commands that achieves certain result. For example, we have a recipe or algorithm for cooking eggs. To cook eggs, we need a plate, we need some other things, and we first break the eggs, put them inside the cooking place, etc, etc, etc. So we have many steps to cook an eggs, and this is the recipe for cooking eggs is called also algorithm. A sequence of steps that achieve certain result from certain input. So programming is performed by people called programmers or developers. Developers because they develop software. They not just program, but they can program. Developers also do create user interface, they debug the code, they talk with the customer, so they do many things additionally to programming. And programmers are just people who write code, who write programs, who write commands. Programmers use IDE. This is called also integrated development environment, like IntelliJ IDEA or Eclipse or Visual Studio. This is a program which is used to write programs. This is a program for writing programs. Like you use Microsoft Word to create text documents and print them on your printer. Okay, you use Google Chrome to open websites, and you use IntelliJ IDEA to write Java code. Okay, so IDEs provide code writing, running and testing the code, like I already shown you, and fixing bugs and debugging the code, something which I will show you later. Okay, so this is a simple Java program, which is a sequence of Java commands. It's assigns 5 into a variable called size, then prints the size, and then prints the area of square of this size by multiplying the size by itself. Okay, and this program, when executed, will show something like this. I will show you this here. So I can say something like var, which means declare a variable, var size equals to 5, and I can say something like print, I will use this template, print area, and I will add the size. I will do something like print the it's not area, this is the size, and square area, and I will multiply size by size and will append it. So now it will print something like this. See, it will be 5. Wow, the size is 5 and the square area is 25. This is how this works. Currently I use Java version 12, JDK 12, which is the 12th version of Java. But this is not important. We shall use the latest Java possible, and this is what I recommend, unless you have a good reason to use previous version. So let's go ahead and explain the entire thing inside the computer program. A computer program is generally a sequence of commands, but this command stays in a class which holds the so-called public static void main string args method. Assume that we always should have a class which starts here and ends here with this bracket, and it should always hold a public static void main string args, this magic string which defines a public static method with or action which is called main and which takes some input arguments, if any, and starts here and ends here. And the commands are written inside. So we first declare something called size, which holds a value 5, which is of type int, or we can use var to in order to use the type of this 5, which is int, and we can print something. So this in the brackets is called an expression. It's expression consisting of some string, the plus, which means append, and some int, which this gives some string as output, and we print it. This is very similar. We'll talk about all of this later. I just wanted to give you an example, so you don't need to know what is int, what is variables. Assignments will have another lessons about this. You don't know to know in details how system out println works, because we'll explain this in bigger details later, but you should get the idea. The idea is that we have class which has name and is declared by writing public space class space the name of the class, opening bracket and closing bracket. Then we have inside the class we have public static void main, and inside it we can write one or several or multiple commands following one after another. Each command ends with semicolon. This means end of the current command. Another command starts here, and another command starts here and ends here. This is a command consisting of two wines. It's not necessary one command to be one wine. It might be several wines. Okay, this is another program which reads something from the user input, the so-called console or terminal. Scanner equals to new scanner of system.in, which means please make me a new scanner, or this is a kind of reader of data which scans the input data based on the system input, system.in. In order to use this, we should put the import Java util scanner before the class declaration. I will show you how to do this. Int dollars equals to scanner dot read the next integer from the console, the next in, scanner dot next in, and we read the some value in dollars. We calculate this in euro by using a fixed rate of 0.883795087. We assume that the rate is this. It might change over the time, but we just assume for simplicity. And finally, we print the euro. So if we put 5 euro as input here, the output from this program will be this. So this is an example of program which reads something from the input and based on this input produces something else after some calculation. Okay, I'll write this code for you just to demonstrate this. It's scanner, and if I put it here, this one appears. See, scanner, it says, oh, I don't know what is this. Do you want to import the class? And I say yes. So it imports Java util scanner before the here in order to use it, because this is an external library, an external class which is not by default included in your program. So we want to say, oh, our program wants to use this class. It might use several classes as well. Scanner equals to new scanner of system.in. I want to scan the input for numbers, for strings, for dates, for many other things that may come from the input. The system in, this is the input here, which is on this console. This is called console. Okay, so we have scanner equals to new scanner, and now I will say int dollars equals to scanner dot next in. See, I have autocomplete. When I click enter, it will be automatically completed. Okay, and now I can say int, or maybe double euro equals to dollars multiplied by 0.88 379 for example. And finally we print this as out, enter. We print euro and we append the euro amount. Let's run this. Right click, run main. Okay, I'm waiting for this to run. It started, and I will write, for example, $5. $5 are 4.41 euro. I can start this again, and I can have, for example, $20, and $20 are 70.6759 euro. Okay, nice. So this is just another example. Again, if you don't catch everything here, it's normal. We will learn how to use the scanner, the calculations, the printing on the console, reading from the console, working with numbers, and many other things later in our following lessons. Today, I want just to introduce you what is programming, what are commands, what is Java, what is to give you some examples about the Java language, to give you some examples how to use this IDE called IntelliJ IDEA, and to explain you certain concepts like algorithm, like compiler, like virtual machine, and many others. So let's go ahead to say a few words about the Java programming language. The Java programming language, which is a modern, highly used, very popular, high-level object-oriented programming language. What does mean high level? Which this means that you can write one command and it will do a lot of things. Well, low-level language. In low-level languages, you should write lots of commands to achieve something like printing, for example, a text on the console. It's object-oriented because it works with objects, something like systemout.println, printer.star, or aircondition.stop. This concept is called object-oriented paradigm, object-oriented way to express actions. Okay, so the programming languages as a concept, they define a set of rules or syntax for writing commands. Different programming languages may have different syntax or different rules. Like in English, we usually, if we write in English, we usually use the capital. For example, I want to start programming, and we finish with dot, and this is part of the syntax. We start with a capital letter. Each command in English or sentence in English starts with capital letter and ends with dot or other special character. In Java, commands end with semicolon. This means I'm ready for the next command. So we have command, which is something, some object dot some action, or we have some other commands which are different, but this is a very typical syntax. So programming languages define a set of rules. It's called syntax. Languages are either driven by a compiler or by interpreter. So they are compiled languages like Java, C#, C++, Go, and others, or interpreted languages like JavaScript, Python, Ruby, and many others. So compiled languages are considered a little bit more faster, and they are transferred into special executable format during the compilation. Interpreted languages don't include compiler. So the compiler translates the programming code into machine code, and this happens during the compilation, and it finds syntax errors. I will show you. For example, I can put this, and I can say build the project or compile the project. See, it will take some time. See here, it says, so I'm parsing, I'm doing something, and it finds the bugs. It says, I cannot resolve this symbol, I don't understand this command. So I can erase it and build again. When I built this, it was successfully built here, and I don't have build completed in 3 seconds. So it takes some time to build the project. Okay, and it will okay, I can rebuild the project to build it again, and it takes some time, and it says I'm rebuild the projects in 4 seconds. So this is a process called compilation, and it is applied when you program in Java, in C#, in C++, in Go, in C, or some other compiled language. If you use interpreted language, it just executes the code one by one directly, and it finds the syntax errors at runtime. There is no compiler. I will show you the Python language. I run the Python and I say, please tell me what is 5 plus 5. It says 10. Can you, for example, put in the size 5? Can you print the size? Can you print the size multiplied by size? So I just give commands, it answers directly. This is how Python works, and this is how JavaScript works. For example, if I have this and if I press F12 and open this console, I can write JavaScript code at the very similar way. I can say, for example, console.log 5 multiplied by 5. It's 25. So this is JavaScript. I showed you Python, and I already have shown you Java. So the interpreter executes codes line by line. This is the case with Python and JavaScript. And compilers first compiles the entire program, prepares it for execution, and executes it later. If you have errors here, F12, if you have errors, you will find the errors when the command is about to be executed, like this. This is the error. If you have errors in Java, you will find them during the compilation. So this says that you might have a problem, but if you rebuild or recompile the program, it will give you the errors. So errors are found, most errors are found at compile time. Java is modern general purpose programming language. What does it mean, general purpose? Means that it can be used for many things, for general purposes, like creating web apps, like creating mobile apps for Android, like making games, or writing backend apps, which, for example, process some invoices in a corporation, or it might be used for many other things. So it can be used for writing business softwares, games, mobile apps, websites, web apps, and many others. So it's modern language because it's alive. It's created in the object-oriented era and evolved during the time and improved many times from 1995. It's object-oriented, which means that Java programs consist of classes, and these classes hold methods or actions. And we use objects like, for example, printer.print this or tv.switch-on. We have object dot some action, and this is this style of programming is called object-oriented programming. It's a good choice for beginners because it's easy to learn, it's easy to read, it has easy syntax, and it has very big community. Community is very important when you learn something because if you have questions and if other people have the same question, you might find the answer in internet if you have big community about something. So there are lots of books, a lot of lessons, a lot of courses, a lot of training programs, and many other things about Java. Java is massive development language, massive, which means that millions of people code in Java. So it's a good start for beginners. If you start programming with some exotic language, like, for example, Rust or Erlang or I don't know, it's not important which one, or Tico, it will be more hard for you because there will be less resources and less people who do this thing, and less books, less resources, and less know-hows entirely in the industry. So my suggestion is, when starting programming, choose something which is massively used. Just like when you start driving a car, just purchase a typical car, a car which is used by many people, like Toyota or Mercedes maybe, but don't choose something which is very strange, like starting to learn driving by a heavy truck. It's not a good idea. It's possible, but it's not a good idea. Okay, so let's say a few words about compilation and execution. Java is a high-level language. High-level means that you write commands which consist of many small steps which the computer internally executes to achieve something bigger. So with less code, you achieve more. This is typical for the high-level languages, and it is compiled, which means that all the programs you write are first compiled, then executed. A program in Java is written in a text format, the source code. This is the source code. This is the Java program, this one. This is called the source code. The class files generated by the compiler are independent of the machine and the operating system. So when this program is compiled, it consists of these class files. I will try to open this in Windows Explorer to show you. So we have something like I need to build it successfully, rebuild the project, and you will find this class, which is a binary file. You will not see anything interesting in it. You cannot open, but this is called a compiled class. So compiler transforms your source code into compiled class files, which can be executed in the Java virtual machine. They can run in any system. For example, you can compile your programs in Windows and run them in Linux, or run them on your mobile phone if it is Android based. So you have the source code, the compiler transforms it to compiled code, which called also Java bytecode, this something.class, and it's executed in the execution engine also called Java Virtual Machine, which is part of the Java runtime environment. The Java runtime environment executes the Java program. So if you want to use Java, you need to install Java. Otherwise, your computer will not know Java and cannot execute Java programs. So let's say a few words about JDK and GRE. JDK is the short form Java Development Toolkit, as the Java Software Development Kit SDK, Java SDK, which is a tool set for developers. If you are a developer and you want to code in Java, you need JDK. That's it. But not only JDK, you need also some other tools like IntelliJ IDEA. But JDK consists of GRE plus compilers, virtual machine, and many other things. In order to run the programs, you need the virtual machine, the JVM, if you want to execute a Java program written by someone else. For example, if you want to run some Java program, let's say OpenOffice, you need the Java virtual machine and Java installed. If you want to create your own programs, you need the compiler, JavaC, or you need the JDK. Okay, JDK is available for free download from Oracle. Oracle is the company which currently holds the development of Java. It provides NetBeans, which is a development environment like IntelliJ IDEA, and it provides the Java JDK. If you want to download it and install it, which we shall do later, you need to go here to accept the license agreement and to download, for example, this file if you are using Windows, or some of the others if you are using other platforms like macOS. So JDK should not be confused with GRE. GRE allows only to run Java programs, but you cannot develop your own Java programs. In order to run Java, you need GRE, which consists of the JVM, some Java libraries, and some others. If you want to build your own programs in Java, you need also the compiler and other tools from this JDK. So we are developers and we shall install JDK. We shall install this one. Okay. So downloading and installing JDK is the first step you should do in order to start with Java. You download it, I already showed you, and it's very easy. Just follow the instructions and it will do the job. After that, you need to install an IDE, otherwise you should write your code in Notepad or in some default text editor, which is not impossible, but it's hard. So let's say a few words about IDEs, Integrated Development Environments. Integrated Development Environments simplify the writing of software. They are tools which help developers to do their job easier, like chefs use cooking machines to cook the food. Developers in the similar way, they use IDEs to develop their software. So IDEs save time and eases the process of coding, and they do many things like simplifying the writing of code. They allow running the code, they allow testing the code by automated tests or by hand by entering some input and output data, and debugging the code. I will show you the debugging in very briefly. Debugging means that you can put a breakpoint here and run the program in the debugger, and it will stop at the breakpoint. It means sometimes because it's maybe the first time I run it, and you can track the execution of this program step by step. For example, I put 25 and now the euro is 25, the dollars are 25, and the euro will be when I press F8. The next line of code will be executed, and now this is the result. So this code tracking or code execution tracking is called debugging. You have all these tools inside the IDE. For Java programming, we shall use in our training course a software called IntelliJ IDEA Community Edition. This is free IDE from JetBrains. I'm not sure whether it's open source, maybe it's not, but you can download it and install it, and be sure to install this one, the Community Edition. Yes. Why? Because it's free and it's enough for our training course. Ultimate has more enterprise features which we don't need, and we don't need to pay in order to use it. Yeah, it's open source Apache license. Okay, so the IDE is something that developers use every day. This is their tool. Like designers use Photoshop and Illustrator in most cases. Developers use IntelliJ IDEA or Visual Studio or some other IDE. To write programs, you need IDE, Integrated Development Environment, and for Java, there are many IDEs already, like IntelliJ IDEA, like Eclipse, like NetBeans, and many others. There are many other Java environments, but these are the most popular. For C# we can use Visual Studio or Radar or Visual Studio Code or some other tools. For Python we can use the PyCharm or Eclipse or Visual Studio Code or NetBeans or Visual Studio. For JavaScript we can use WebStorm or Visual Studio Code or Visual Studio. So there are many programs which developers use to write code and to build software, which involves many other actions additionally to just writing the code, to execute the code, to debug the code, to design user interface like forms with buttons, with lists, drop downs, etc. To install the JetBrains IntelliJ IDEA Community Edition, you just download it and follow the steps. If you cannot install for some reason, for example, you have very old laptop, you can use an online IDE like this one, compile-java.net, and here you can write your code. I will put this for shorter. Just you can put your code here and run it. It will be compiled and will be executed. Oh, it says I don't know what is scanner. I'm not sure why this happens. Scanner, no such element exception. Aha, because I don't, it reads something from the console, and you command to enter arguments. You don't have the ability here to write this. I will show you another repo it Java. So this one works better. This is another online compiler, and you can use this, press run, and it started. So you can put here 5. Wow, how I can put 5? I'm not sure whether this runs. Aha, I put maybe it's slow. I run it again. I put 5 and enter. Oh, don't use such tools. They are, yeah, very, very, very slow. You may find a better place to run these things, but generally it's better to have a local environment. I will add this example here in order to have it in mind when you, for example, this one. Similarly, if you want to code in C# online, we can use this tool, .NET Fiddle, or if you want to write in Python, you can use RepoIt, or if you want to write in JavaScript, it's the easiest thing. We can press just F12 in your web browser, it will open the browser console, and you can write JavaScript code directly in the browser. This is an example how to use this compile-java.net. I will show it. Still, if we don't have the scanner, we can just say system.out.println 5 multiplied by 5, and it should execute, and the output is 25. But again, install a Java environment. There is Eclipse for Java. You can try it. This one. You can also use NetBeans. This is the NetBeans IDE. And you can find others. Java IDE, if you write it, you'll find the IntelliJ IDEA, you'll find some others like Oracle JDevelopers. See, these are the IntelliJ IDEA, NetBeans, Visual Studio Code, or CodeEnvy, or Eclipse, or many others. But just install IntelliJ IDEA and it will do the job. If your laptop is slow, get a better laptop or learn to wait. So IntelliJ IDEA is one of the best IDEs, development environments for Java developers. It runs on any platform, in Windows, in Linux, in Mac. I will show you mostly Windows in our training course, but if you use Mac, it's very similar how to install and run it. You download the community edition and install it. Use the community because it's free, and this is what we'll need. And after you run it, you can create a new project. After this is how it looks like. It holds something called Project Explorer. Out one shows and hides this Project Explorer, and it holds our classes. This is our project, and inside it we have some classes, some many programs, let's say. Okay, and the project source code consists of .java files, which are also called Java classes, and they are compiled here. Here is the output from our compilation. So this is the source code, one or many files, which are moved here as a class files when compiled. And after that, this can be run and executed and run, of course. Okay, so I'll show you how to create a console app in Java. Assume we start an IntelliJ IDEA for the first time. It will be something like this. It will say, welcome, what you want to do. And I say, I want to create a new project. And this new project might be in Java or in Kotlin or in Groovy or in other Java-based language. I need to select the project SDK. If you don't have this, it will be a red message here, and you should use new and select the home directory where your Java and JDK is installed. If you don't have Java, you cannot use IntelliJ IDEA to write Java programs. So you need to have two things in order to write your first Java program. JDK, like I have here JDK 12.01, and also IntelliJ IDEA. So we click new project, we select Java project, and we create from template, for example, command line application. Leave this empty. Leave this empty. Otherwise, you have packages. Your code will be split into subfolders. It's not a good idea for beginners. So the project name might be my first Java program, for example. Okay, it will be located in C projects, my first Java program, which is a good location. And when I click finish, this is what I get. Here I have the source code of my classes. I can reduce the size here. I can use the control and mouse wheel to increase the font, and it says write your code here. So I will write my code here like system.out.println of my first program. Something like this. What I'm missing here is the semicolon. Okay, I will run it. Run my first program. It takes time, especially the first time, but later it runs better. So it prints my first program. It's correct. Oh, this was from the debugger a few minutes ago. Okay, so creating and running a simple console apps starts from new project. I demonstrated this already. You choose command line app or Java Hello World. You can try both, and you give a project name and leave the package empty, because by default is com.mycompany, which will make things more complex. You don't need this. You want to start from the most simple thing, and over the time you will make things complex and more complex. Okay, so if Node.jpg is configured, only once this will be shown. Okay, and this is one time, and you should use new and use the JDK. If you don't have JDK, download and install it. use the latest version, maybe 12 or 13, or I don't know which will be your latest version. Mine is 12, Java 12. Okay, so this is one time step, and after that the commands are written here inside the, you have public class, and here you have the place to write the code. It's between the opening and the closing bracket. You can go here and click new line, enter, and it will open the place. Just what I did. If you have this, okay, you go here, you press enter and write some commands. First command, second, third command, and of course these commands are incorrect. If you try to run this code, it will say, oh, sorry, you have problems. You have 3 errors here in this file. I will delete them. And something important is that your code is written by indentation. This means that when something is inside something else, it should be indented on the right. Which means that when, see, this is the start of our method, this is the end. And everything I write should be indented, should start on the right from this vertical line. Why? Because otherwise the code is hard to read. So this code formatting improves the readability. I'll show you. Systemout.println of hello Java, for example, and I will run this. It will work correctly because it's correct program. But if you put this code like this, it's hard to be read. Okay, can you say whether this program is correct or not? It's ugly, it's unpleasant. So another way to build an unpleasant program is to not use indentation. See, this is a correct program, but can you obviously see where this closes? The concept is in programming is that when something opens and something closes, the things which are inside should be moved with one tabulation on the right. So I select this code with the mouse and I place the tab key on my keyboard. Okay, this moves the code on the right, and also Shift plus tab moves the code on the left. I'll show you. See, tab moves on the right, Shift tab moves the code on the left. So we have opening bracket and closing bracket. These should stay one under another. See, this is the start here, and this is the end. This is the start here, this is the end. See, and this should be moved on the right with one tabulation. Even if I break the code, I can say refactor, reformat. I should find this. Maybe I need to do like this. Refactor, reformat. Column. Okay, I don't know how to reformat. It was changed. It's might be folding. No, it's analyzed. Code cleanup. Okay, I will maybe use code reformat code. It's not given in the context menu. Control Alt L, reformat code. See, it's correctly formatted. So this is something which, if I have second command, and if I put the code incorrectly formatted, like this, see, it's very bad idea. If I say code reformat code, it will be automatically formatted correctly. So this one tabulation and second here is called indentation. Indent, moving the block of code on the right. It's very important in programming, and you will become familiar with it because we'll always use it from this time on. Okay, how to start the program? You can just use the right click run, or it is like it says Control Shift F10. To start the program, we use Shift Control F10 or the right click and run in IntelliJ IDEA. See, right click run, which says also here Control Shift F10. Okay, this one. Control Shift F10 and it runs the program. If there are errors, they will be shown and in the message window, and the program will not be launched. The result appears down, and we already know this. This is just animated, the same thing which I already showed to you. So this is how we start programming in IntelliJ IDEA. It's very simple. The next thing I want to show you is the judge system which we use in SoftUni. For many problems and during the exams, we use an automated judge system where you submit your solutions and the system says whether the solution is correct or not, and if there are problems it says what are they. So your program Hello SoftUni can be tested here in this link, judgesoftuni.org. So we need to press compete or join this, it's called contest, and here we have the Hello SoftUni. It accepts C#, Java and other code. I will use here Java and we'll print this. We'll submit it and it's successfully sent, and I need to refresh. It says incorrect. If I click details, it expects Hello SoftUni, but I print Hello Java and second comment. So I need to fix this. The problem statement is to write a program which prints Hello SoftUni. Okay, this program, Shift Control F10, is the way to run it and check it. It produces the correct output. I can copy it, go in the judge, paste the code here and submit it. After that it says that it's correct and I have 100 out of 100 points. So this is all you need to know for this. Most probably in the next few months we'll change this judge system, the user interface, and will give you a more simple integrated way to check your problems and to get the feedback whether your assignment is solved correctly or not. So, but this is the process in short currently that we currently have. In order to test certain assignment, certain problem, it should be prepared in the judge. You cannot test any problem. You can test only problems which are there already published. Okay, I will explain you finally before the exercises some typical program errors you can encounter if you write Java code. There are many. For example, if you write the code outside of your class. I'll show you. If instead of here you write this code here, what you get is something that says, oh, you need to have class or interface, because here you can just only define classes or interface. You cannot put commands. If you try to run this, it will say that you have errors. Okay, so what else you can mistake? You can put this here instead of in the class, but out of this main method. This will also produce an error, but it will be different. It says illegal start. The error messages are not very informative, but this is the problem. What else you can mistake? You can put system with small letters. Java is case sensitive, which means that small letters and big letters and capital letters are considered different, so it does not exist. It says that it cannot understand this. Or you can write system with big letters, capital letters, it will also not work correctly. So you should say system dot or if you put here, for example, comma instead of this, it's incorrect. Or print ln with capital letter, it's still incorrect. Also, but it will give you different error message, because now it finds system, finds system.out, but it cannot find println. Okay, or if I use write, or for example write one, it says, oh, I don't know this, it's println. It's not print1, it's not print1, it's println. Okay, if I forget to use the comma, like in some other languages this might be correct, this is a syntax error, which means that if you invoke an action and you want to pass parameters to this action, for example, you say println and you say what to print, for example, the number 5 or the text hello softuni in quotes, this will work. If we forget this bracket, it will say, the compiler will say that you need to put this bracket. If you forget the semicolon at the end, it will say that semicolon is expected. See, semicolon is expected, etc, etc, etc. You can forget this quote, it will say, oh, you have unclosed quotes, so you have a string which has started but didn't end it, and many others. But the concept is that some problems are underlined by the IDE, by IntelliJ IDEA, and are discovered during the compilation. Some problems may not be discovered during the compilation and can't occur in runtime, but we'll talk about them later. So writing outside of the main method is one problem. Wrong casing, character casing, like system with small letter or println with capital letter. Other problems are the missing semicolon here at the end of the commands, or missing quote or bracket or closing bracket or other. I'll show you one more problem, is the name of the class. This is just a name. For example, I can name it hello softuni, but this is also a problem because in Java the class named hello softuni should stay in hello softuni.java. So this main here should match this main or Hello Softuni here. So if you want to use Hello Softuni, we should rename. I should refactor, rename this file and make it hello softuni.java. So if this file is called hello softuni.java and this class is called hello softuni, the program is correct. But if, hey, run it, what happens? Oh, it's very slow at the first time, but at the second time it's faster. If this is called main, here this should also be called main. Okay. What else you can mistake? You can forget this, and the program is correct, but it cannot run. See, it cannot be run. There is main method not found in the class softuni. Please define the main method exactly as this. You see? So if the main method is with capital, it's the same. If it is not static or if it is not public, this will also be the same problem. So use public static void main string args. Just use this exactly like it is written. This is how Java works. Now I will show you my solutions. I will be very happy if you have found a way to solve them independently of me. So the first exercise is to print hello Java. It's about writing a Java program which prints the text hello Java on the console. It's really pretty easy, so there is nothing hard and different than what we already did. I will create a new file for this, a new class. Here I click new Java class. See, at the source, my first program, source, new Java class. If it is not unfolded, src new Java class, and it will be named to match the problem title, which is hello Java. Okay, it's hello Java. I need to put here public static void main, there is a shortcut psvm, enter. It prints this long story because otherwise I should write public static void main string args like this. It's the same, and I print as out, which is the same like system.out.println, and print hello Java. To run this, I click the right mouse button and say please run hello Java, and it will print hello Java. I'm ready with this problem, and this is what I have: solution, print hello Java, etc, etc, etc. It's exactly the same. Very simple program. This is also called the hello world in programming. Program which says hello, I'm here, this is a program, it runs, I'm happy. Okay, so the next example is a program assignment to calculate and print 5 multiplied by 5. The easiest way is just to see 5 by 5 here, but it's better to create a new program because otherwise you will lose this one. So again, src new Java class, and what will be the name of this class? Calculate and print 5 by 5. Expression 5 by 5, for example. It's a good name which answers the question what's inside. It's an expression 5 multiplied by 5, so it's a good idea. PSVM. So we have sout println 5 multiplied by 5. Right click, run. We are ready with this problem. Let's see whether it works correctly or not. It's 25. Looks that it works correctly. The solution I have in mind is exactly the same. It's very simple. I'm sorry that the problems now are so simple, but it will take time until we learn more complex constructs in Java programming and to have more complex problems, like when we learn about loops, about nested loops and things like that. So step by step. The next problem is called name and expression. It's about writing a program to print your name at the first one and calculate and print the expression 5 multiplied by 3 at the second one. So this involves two commands. The first prints your name, for example, print Svetlin or Ahmed or Camelia, for example. And the second one should print something else. For example, a sample output might look like this: Mariah and 8. By 5 plus 3 is 8. Another good example of valid output is Peter, if your name is Peter, and again 5 plus 3 is 8. So this is called name and expression. I'll click new Java class, name and expression. Don't use spaces. Spaces are not allowed here. See, because it's you cannot use spaces in the class. So use this naming. Capital letter for the first word comes, the next word comes with capital letter, and the next word comes with capital letter. Name and expression. PSVM and sout and 5 plus 3 at the first one, at the second one, and print my name. My name is, for example, Svetlin Nakov. I will run this, and what you see, oh, incorrect. Why? Because I run another program. See, I don't run this. I want to run name and expression, not the others, because I have one program, second, third, fourth. I have 4 programs. I want to run this one. I have 4 programs inside one single project. See? So if you have many assignments during your lecture or your training session, you are encouraged to create a separate class for each of them. So this is my solution to the name and expression program. This is another solution, Mariah's solution. She wrote her name and the 5 plus 3 expression. And now we have a little bit more complex program, which involves printing the value of 4 expressions. It's called calculations. So I will again create a new class which will be called calculations. Okay, I will write the main method here, and then I will print the first expression, 5 plus 3 multiplied by 2. Okay, I'll copy the others. This is the second, because I don't want to just write them again. Control C, Control V. Control V doesn't work. Oh, it works, but not as I expected. What happens here? Oh, this is something which is not space. See? Looks like space, but this is not space. It's something else. So you need to put the space. Sorry, copy paste sometimes doesn't work as expected. And this is the final one. Control C or copy and paste. Ah, it doesn't work as expected. Yes, so it might be easier to just copy, to just how to say, to just type the text again. But we're ready finally with this problem. We solved it, and let's check whether it works. 1126. 1126 looks like it's correct. The other solution coming from the already prepared slides is very similar. So we have nothing different than just printing the expressions as they are given. The next problem is about printing a square of 7 by 7 stars. So we have a star, then a space, then a star, then a space, and this is 7 times. Okay, and we have this thing repeated vertically 7 times. So we have 49 stars. Okay, how to print them? I know a very simple way, and I will show you. Then I will show you a more smart way. So again, I go in IntelliJ IDEA in my project, and I say Java class, which will be called square of 7 by 7 stars. Square of 7 by 7 stars. Okay, and again I have public static void main, and again I have something like please print this 1 star space 2 3 4 5 6 7, and I can copy this. I select this, Control C, Control V, 1 2 3 4 5 6 7, and now Shift Control F10. I run this, and it works correctly. But this is repeated many times. Can I repeat it in a more smart way? Yes, I can. This is done by for int e starts from 1, e is less than or equal to 7, e plus plus, and this is inside. Did you see the indentation? When I put this code inside these brackets, it moved up to the right. So this is called for loop. We will learn about it after 5 or few lessons. For now it's out of scope for today, but I just want to show you, if you are curious, how to repeat something many times. So this is the same output produced by this square of 7 by 7 stars, and if I go in the judge system, I can I don't have it, it's a different but if I find this, I can submit it. Maybe it's here at the rectangle. No, I don't have this. I have other nums from 1 to 20. This is supposed to print the numbers from 1 to 20. This is another problem. Okay, I will not submit it because I don't have this in the judge. Let's see what else we have. We have this first solution and this second solution, which starts from 0 to 6. I made a loop from 1 to 7, but it's the same thing. Repeat something 7 times. So we are finished for today. We talked about what's coding. We explained that coding, it's about writing commands and programs. Programs consist of several commands coming one after another. And we explained that the Java language is a popular, widely used programming language, high-level, object-oriented, with a very big community, and we recommend to use the IntelliJ IDEA community integrated development environment in order to write Java code and installing. I showed you how to install Java and IntelliJ IDEA and configure it, and finally how to write Java console applications, how to create a new project, how to create a new class, how to put some code in the class, how to write public static void main, how to run the code with the right click or with shift control F10, etc, etc, etc. So now we know what is coding, and I hope you will like coding and you will come for the next lesson where we will talk about variables and calculations, and for the next few lessons where we will use conditional statements, loops, and many other pieces that we combine to write more complex programs. In this section, I will talk about variables and data types, such as string, integer number, floating point number, boolean, and others. Also about statements, which define the commands in the program, and the most used arithmetic operators like plus, minus, multiply, divide, and remainder, and the expressions in Java, or how to combine operators with values to implement a calculation. I will explain and demonstrate how to implement a console-based input and output in Java. I will show you how to read user input, format and print output to the console, and how to read and print text and numbers. I will teach you how to use the Java Scanner class to read text and numbers, and how to work with integers and decimal numbers. As homework assignments, you will have several hands-on exercises related to reading some data from the standard input, performing simple calculations with the input data, and printing some output in certain format. That's it. Let's start. Okay, let's start with this. So the first thing we need to introduce today is the so-called variables. Variables as means of storing and processing data, as memory locations which are given a name, and these locations that hold some data which can be modified later. So how does computing work in general? Computers are machines that compute, machines that process data. So computers are data processors. They take some input from the user, from the keyboard, from the mouse, from the microphone, from the joystick, from the internet, whatever, and they process this data. For example, they take data holding a video stream, they process this data, visualize this stream or video on the screen, and finally they output something like display something on the screen, or print something on the printer, or send something over the network, etc, etc, etc. So computers are computing machines. They work with data and they hold instructions and data, and both of them are stored in the computer memory. Computers have memory, and this memory holds data and holds their programs, their instructions, their commands, which they execute one by one and to do their job. So data is stored in programming using variables. Variables are named locations of the computer memories holding certain value. So one variable is located at certain place in the computer memory. Other variable is different at different space, at different place in the memory. So variables are containers for data, containers for information, a named area in the computer memory, and the data can be read and can be modified or changed at any time. So the memory, also called RAM, RAM, read random access memory, which means that you can access the memory at random locations and you can change it and process it at any time. So variables in programming
provide means for storing data like person name, like account balance, such data, and they can retrieve this data by the variable name, and they can modify the stored data for later use. For example, if I need to open an account, I will store the data about the account in the computer memory. Probably I will store this in the database also on the server's hard disk, and later I will retrieve back this data and will modify it, for example, when I pay something. So variables are characterized by name or identifiers, for example, username or password, or it can be account or account balance. This is the name. They have type of the information preserved, like their type can be string, can be text, can be date, can be picture, can be video or other type, and they have value. The value is the actual data stored inside this variable, which may change over the time. So this is the syntaxes for defining variable in Java. In Java, I can say int age equals 25. So this int is the data type, this age is the variable name, and this is the declaration, and then follows an assignment or initial value which we give to this variable or which we store in this memory location. So variables are named areas of computer memory, and they store a value from particular data type, for example, integer value or numerical value or text or date and time. And variables values are accessible in the program by the variable name. So if I have a variable called student, which holds the name of the currently logged in the system used student, I can access the student name by this name student, by the variable name. So variables can be stored in the program's operational memory in the stacks, in the execution stack, like integers do, like floating point numbers do, or in the dynamic memory, like when we hold texts and others. The dynamic memory can be changed over the time it's sized. So operational memory is usually used for fixed size variables, which are small. This is the so-called execution stack. The dynamic memory is related to the so-called pointers, variable holding address in the memory, which holds the actual data. We'll talk about this later in our trainings at SoftUni, but I just mentioned them now. So let's show you variables. I will start the IntelliJ IDEA, our favorite integrated development environment, and I will create a new project especially for the today's lesson. Today's lesson is about data type, variables, and calculations. I can name the project calculations or something like this. It's starting very slowly, I don't know why. But it's time to drink a small coffee. Okay, please start. What happens? IntelliJ IDEA is starting. It shows a sign of starting, but still not started. Did you see the image below the so-called what is it? The starting screen. It's still starting. I cannot believe. My laptop is truly fast, but this is incredible. How slow is this? Okay, finally it started. So I create a new project with IntelliJ IDEA. I click create new project. It will be Java. I use Java 12 configured, and I click next. Then I say, please create a Java Hello World application, and this application will be named calculations examples, because today's session is devoted to calculations or calculations examples. Okay, I will finish this and it will take, I hope, less time to finally have this project and being able to write some code. Okay, so I have a project here which holds one class in the source called main.java, and in this class I have a few lines of code. Okay, so let's go with variables. Int age is 20. So console write line s out system.out println this age. If I run this application, right click run main, I will see this age 20. Okay, it's slow only for the first time. Later everything is cached, pre-processed, and it's no longer slow. But okay, this is the age, so I can print also age and this age. Run it. Okay, so I can print the variable content like this, age 20. So, but later I can say age is 21 and I can print the age again. It will be the new age, which shows you that the variable value can be changed over the time. I click Ctrl F5, so it says first the age is 20, later the age is 25. I can run this through the debugger. I'll put breakpoint like this and we'll say debug. Okay, and now the program will be executed one by one and I will show you how variables work. So I have int age is 20. I press F8 and now but let me see, yeah, these are the values here. These are all the variables here in my program. I can have hundreds or thousands of variables. When I print it, it will be printed. So the output is like this. Okay. When I go at the next line, I press F8. Now the age is 21. It just got changed. Its value got changed, and I print this variable, and I have the output here. So this is how it works. I can just stop this debugging session and stop the program execution and this debugger session. Okay, let's go ahead. I explained to you that the variables are named areas of computer memories which store data which is accessible, and it can be stored at different locations, but this depends on the type. I'll show you another example. String name. Okay, name is Svetlin, for example. So I will print the name of the person, then I will say name equals to, for example, Mariah. I change the name and I print the changed name. Very similar. Ctrl 5. I believe we'll do the running of the execution of the program. So it's first name Svetlin, then name is Mariah. I can run it through the debugger or without the debugger, but it's not quite important. The important is that I can have variable, it should have a type, and the value is on the right. Instead of this, I can put var. Var means that the variable will have the same type like the assignment expression at the right. So this is a string, okay, and this name is of type string. This will work again. This var syntax is only available in the latest Java versions. It was introduced in Java 12 or 11, I'm not sure. Okay, let's go ahead with data types. Data types are, in short, the ranges of the variables, of the values possible to be assigned to certain variable. I will give you examples. So the data type, variables can store value of certain type. For example, here the variable type is string. If I try to assign something like name is 15, this will not compile. It will say, oh, we have incompatible data types. We have variable of type int, and you are trying to assign, you have variable of type string, and you are trying to assign a value of type int. It's not good, it's not possible. Or if I try to assign 15.4, it's a value of type double, a floating point number, and I want to assign it in a variable of type string. This cannot work. So variables have type, at least in Java, and in Java the type is explicitly given, explicitly explained, and variables cannot change their type over the time. In some language we can change the variable types over the time, like in Java or Python, but in Java, like in JavaScript or Python, but in Java and C# we cannot, because these are strongly typed languages. So variable type can be a number, or letter, or text, or date, or color, or picture, or a list of something, or a list of images, or it might be a count, it might be many things. But types define the range of the possible values. For example, if the type is integer, it should be an integer, a whole number without fractional part in it, and it has a certain range. For example, the int type is from -2 billions to 2 billions. Data types like int are integers, just like 1, 2, 3, etc. Double is a floating point number like -0.5 or 3.14. Boolean is a special type which can hold only true or false, yes or not, agree or disagree. This holds a Boolean condition, whether something is true or not, or where something happened or didn't happen. Char holds a single character, single letter, for example, A, for example, B, for example, the dollar character, or the question mark, etc., etc., etc. And strings hold text, like hello, like just a word, a sentence, or a whole book can be put in strings. Strings hold texts. So we'll work with strings later in our next training course called Programming Fundamentals. Okay, so data types might be defined sets or ranges of values with similar characteristics, like numbers, like dates, etc. So data types are characterized by name. Data types have name, like Boolean, like int, like string in Java, and these are related to certain Java keywords or classes. They have size. For example, the int type is 4 bytes. The Boolean type is 1 byte only, just 1 byte. Okay, some string hold 4 plus variable number of bytes. For example, if we hold a short message like hello, it will be something like 10 or 12 bytes, something like this. If we call one book, it might be megabytes, it might be thousands or millions of bytes. So strings are variable size variables, and they are kept in the so-called dynamic memory. Variables have default value, like for example, if we have integer and we don't assign a value, it will be 0. If the compiler allows this, because in most cases it will just say, oh, it's an error, please don't do it. Okay, I will give you examples with the other types. For example, Boolean, valid, says, for example, true. This is valid. Is it valid? Yes, it's valid. Later I can change the valid to false, for example, new value as the so-called valid. Is it valid? Initially true, I started the program, later it's false. Okay, valid true, valid false, but I cannot say it valid plus plus. It's invalid operation, or I cannot say valid is Peter. It's invalid operation. Okay, it will not compile, it will give errors, etc, etc, etc. So it says I cannot assign to a string value to a Boolean variable, something like this. Okay, other examples are, for example, date. So I can say date t is equal to new date of I'm not sure whether I can create a date from year, month, and date. This is deprecated, but it will do the job. For example, something like year 2019, month, and this, and I will print the date. Just an example. This is not the correct data type for date. I believe it should be local date. Yes, this is the correct new local date. But this doesn't work. It should be I don't know how to work with dates with Java. Dot from dot of date of year, month, day of month. Finally, looks like I managed to learn how to use the Java time local date. So this is a date. This is something which we shall use if we, for example, program ERP system which will hold the orders in online e-commerce website, for example. So I cannot change the date like date plus plus, but I can say t dot at or t dot I should see how to work with this, but d dot plus days of 1. D equals to d plus days. Please add 1 day, and the new date will be something like after the 3rd of January. The new date is 4th of January. Just an example. Okay, so this is to get the idea that we have different data types like date, like text, like number, etc. And this is a normal. We have the same in the spreadsheet, in Microsoft Excel, for example. And this is something normal if you have a table of holding some data. It might hold different data like the purchase date. Like, for example, if you have an invoice have a date of the invoice, which is of type date. It has the company name of the supplier and the company name of the buyer. It has also the ID number, which is usually some kind of integer, etc, etc, etc. So let's go ahead after the data types to statements. Statements which are commands in the computer program. They are the basic units which build our programs. So one statement, it's one command, but technically it's called statement. If you learn a new language, you will see that We have statements, we have expressions, we have conditional statements, we have loops, which are different kinds of statements, etc., etc., etc. So the actions that a program takes are expressed as statements. These statements or commands or actions include things like declaring a variable, like int counter semicolon. They end with this semicolon, which says this is the end of the statement. There is no more things coming after that. No, this is the end of the current statement. So a next statement is coming after that. Assigning a value is done like this. Variable equals to value. Declaring plus initializing might be combined like here. So we have int counter equals to 1. This separately is very rarely used, almost not used. This, this one here is what we usually use in programming. Another kind of statement is a method invocation or command, or how to say, action invocation. Please find the class system, find its output, and invoke the println method and pass as a parameter this counter. So it's a kind of a statement which says, please, which consists of several parts, of several actions. Please find the system. In the system, find the output, the standard console output, and then tell the output to print something and give this something as a parameter. This in the brackets, values given in the brackets are called parameter or parameter values. So another statement is to modify the value counter plus plus, and another statement is to calculate an expression just like this, a plus b, and assign the output, the result of this expression, here in the variable. So I will show you all of this. First, I can declare a variable. For example, int I. If I try to print I, this will tell me, oh, this may have not been initialized. If I try to run this program, it will say, sorry, you are trying to print something which does not exist, which still doesn't have a value. So I should do something like int a is 10, or declare a, and later say a is 10. And then I am able to print it. So I can run the program with pressing Ctrl F5. Oh, and it says it's 10. I can also combine this int a, the declaration and assignment, and do this. I can print many commands, just like instead of system, I can do something else. Like I can say, for example, process dot new process dot something. So I will create a new process. This is more complicated, but I can try something like system dot, it has exit. I can say, please system, please exit, and the return status code is 0. So if I exit the system before printing I, the program will stop before printing I. So the concept is that we have object, some object dot some action, and this is the action. Or it might be like this, object dot sub object dot action, and after that we have brackets and we have some parameters. This is how statements are usually constructed. So I may have system out, not println, but these are the possibilities here. Dot append, please system dot out dot append of this character. and then system dot out dot println I. Now if I run this, it will stop here. I will delete this one, but now it should print $10 because it first appends at the output of the current process here at the standard console or terminal. It prints something, then it prints something else. Okay, so modifying a value I++ or I equals to I multiplied by 2. So we have here I will be 11, then I will be 22. And this will print $22. Let me check. Works. So another thing I can do is to say int sum is equal to I plus b, where int b is 20. So I have 10 plus it's 11 plus 20. The sum will be 31. Let me check. Is it $31? Yes, it is. So this is how different statements work. This is a declaration statement with assignment. This is a method invocation statement. This is a variable increment statement. This is a variable declaration statement. This is a statement of variable declaration plus assignment, which holds an expression. And this is a printing expression. I may have more complex expressions like for, which says int x is 0, x less than 10, x plus plus, and this prints x for each x from 0 to 9 or from 0 to 10. It's like this. So this is a complex statement holding a nested statement inside it. Did you see the output? We'll talk about whoops later, but we may have a group of commands closed into brackets, and this for will execute this group or set of commands here. So see the output. The output will be 0 hello, 1 hello, until 9 hello. So we have many commands to be repeated. This one is a composite statement consisting of several statements inside. Okay, so all of these types of commands in the Java language are called statements. They are just the commands we use when we program, and we have statements in any programming language, in Java, in JavaScript, in Python, in PHP, etc. So the next topic I will talk about, it's about reading the user input and printing at the output, formatting the output. This is something which is usually related to the place we take the input and output from. We'll use the so-called console or the so-called terminal window or the standard input and output. This is the standard location where data comes into a certain program and where data is printing when the program prints something. So what is the console or terminal or the standard input output? This is this window, okay? Or also this window. This window here is called the console. I will show you. If I run the Windows console, which is called command prompt, CMD, I can put something and it's trying to execute my commands. If I write something which is very long, see what happens. It directly goes to the next line. Do you see? This is a standard way that it's supported by the console. So I'm trying to enter many things. if I print many things, the console, oh, I'm trying to, okay, it's trying to execute the command, but see what happens. The console has a scroller and it might change the information displayed. So it may hold more information than the screen can hold. Do you see? So I have a scroller. This is a standard concept in computer systems, so I believe you will catch the idea. The console is usually holds this black background, but sometimes it looks like this. Or I may have this terminal, which is also a console. I can write commands like dir, which displays the content of the current directory, or exit, which closes the console. This is the so-called terminal. Okay, so this is the console. I mentioned the concept. It's a special window or piece of the window used to communicate with the user. It's very important that the console is text-based, is based on printing something at the command line interface CLI or at the console or at the standard output and reading text. It displays text data or text lines and it reads input, which is also text. The console is always text. It's not possible to print an image or play a video at the console. It comes from the time where the computers were just taking some text input and printing some text output, and they were unable to play video because they didn't have so high quality screen with so many pixels, and they were unable to display an image or also to display to play a sound. So the console and console applications will be our start. Later we will write further in our trainings at SoftUni. We will write web applications, mobile applications, and applications which have different input interface and output interface, like the screen, like the web browser, etc., etc., etc. So our training course called Programming Basics with Java will use the standard input and output console or terminal window, this which is in Java represented by system.in and system.out. How to read something from the console. We already know how to print something on the console out println, but how we can read, we should first know that everything we read from the console comes as a string because it's a text. So if we want to read a user input, we should use this system.in. But system.in gives you the opportunity to read the text coming from the console letter by letter. You usually don't want to read the input letter by letter, but you need the output one by one. For example, if you want to read a person's name, you don't need the first letter, second letter, third letter of the name, you just need the name. So this is the way we do it. We write this line of code, which creates a scanner. It's a kind of specialized text reader for text, which is connected to the standard input for the current process, for the current program. Okay, so it's something like int I equals 10, but this is not int, it's a scanner. We give some name, like scanner with small letter, equals to new scanner, and this is called a constructor invocation. So please create a new instance of this scanner and connect it to system.in. Just remember this, it's always the same. One day you will learn about classes and objects and you will learn better how this works, but just assume it's like this. Once you have the scanner, you can say scanner dot please read the next line from the input. And everything we print on the console is also converted to string. So we say print system.out.println, like hello world, and this is a string. Strings in Java are given in quotes. So we can produce strings using a string expression. This is called a string expression. We have a string and we combine this string with this integer number, and the result is hello123. It's another string, but it's string based. The console is string based. Okay, I will show you how to read from the console. So it's something like this. Scanner scan equals to new scanner of system.in. Please, the system input, read it. Open it for reading. So I will say scan.next line, and this returns a string. String input equals to this, and I can as out system out println of this input, and I will say input from the console was this input. I will run this program and it will stop and will wait me to put something like hello. It says I read from the console the word hello, or I can say today is sunny day. It reads today is sunny day. So this enters in this variable called input. I can even say something like please type something, just to tell the user that he needs to type something. Please type something. Okay, something. Okay, something. This is what was read. So this is the way we read from the console, and this is the way we print at the console. We already know this. We can read the input and print it 3 times. So now I will print something. I'm happy, and the computer prints I'm happy 3 times. Something like this. Okay, so this is generally how we read user input when it comes as a text. But sometimes user input is not a text, but it's a number, or it might be a different thing. But first, let's go ahead about the formatting output. I can print something like John is 19 years old. I can do it like this. Let me show you. String name is John. Okay, int age is 19. So I can print that John, the name, plus is plus age plus years old. See what will be printed. Okay, John is 19 years old. Maybe I need to have 1 space here additionally. And now John is 19 years old. But I can print this differently. System.out.printf, print formatted, and I will use a pattern with placeholders, and it will be someone is some decimal value years old, and I will print the name and the age here. See, the result will be very, very similar. John, this percentage S, will be replaced by name. You see, this name will go here at the first placeholder, and this %d will mention age, the second placeholder. Okay, so this is how this works. Let me show you. %s means placeholder for text. %t is placeholder for integers. And there are other placeholders, but we'll mention them later. %f is placeholder for floating point numbers. And we can also format this floating point number like this, %.2f, which means print a floating point number just like with 2 decimal points, with 2 digits after the decimal point. I will demonstrate this to you. So I may have a double value. Double size is 20.5. Size is equals to size divided by 3, and now print the size is was the size. Okay, see what happens. This will print the size, but it will format it like this. I want just 6.83, just to cut, to use the first two, exactly 2 digits after the decimal point. So I can print something like this. Print f, the size is %f or %f, and comma the size. See what happens? It will be the same. But when it's not the same. It's by default it's formatted different. But I can say .2f, which means exactly 2 digits after the decimal point. See, if I use .3f, it will be 3 digits after the decimal point. Even if I don't have 3 digits, zeros will be given here. See, 20.500. I can have this, or I can have something like 0f, which will be just maybe 21. Yes, it's rounded to the next number. If it's 20.4, it will be 20. It has rounding, like 2075.9 with 2 will be 20.76. Can you see it? This is how it works. So this is called placeholder based formatting. You can have a text, you can have placeholders in this text, and you supply values for these placeholders, and they are replaced during the printed with their replaced text. So if I print this 2 times, it will print something which you don't expect. See the first output and the second output, but there is no new line. I can print new line just by println. The first variant, so it will work like expected. I can see something different, for example here with 3 digits after the decimal point, but I can just print /n, which means a new line. It works correctly, just it's very slow, I don't know why. Or it might be %n, which is a placeholder for the new line. It's nearly the same. So this will also work correctly. So this is the way we use placeholders in Java to format strings. Let's continue now with a few more examples about reading the user input. I want to write a program in Java which reads a name from the console and prints it. So this program might be like this. I create a scanner which will read the system input, the input from the console. Later I say next line and I read the next line coming from the input and I put it in the variable called name, and then I print the name. Okay, after that the result from the execution will be something like this. I write some input, for example John, and I get some output from the program, for example John again. I already demonstrated this, so I will go further about reading integers. Reading integers is something like, please read the next line, which is a string. It is a variable of type string, and then convert it to integer using integer.parseInt, and later use this number. Or this might be done shorter with scanner.nextInt, please read the nextInt, but using nextInt, nextFloat and similar might work not like you expect, because they are reading token by token, and if you want to combine reading ones and ints, it might run incorrectly. Be warned. But generally the second way to read integers is shorter, so it's recommended in most cases. This is an example. We are given we want to write a program which is given the side A of a square, and it wants to calculate the square's area. So we read the side A, we multiply A by A to get the area, and we print this area. I will demonstrate this to you. A square area. I will even create a new class here, which will be called square area calculator, because this, what does it? As calculate the area of given square. Okay, square area calculator. I will write the main method with main and enter, and then I will say something like scan equals to new scanner of system.int. It's not imported, so I will use alt enter. It will import the class. It will print import Java to scanner, because I cannot use scanner, it's incorrectly written here, before I import it. If I remove this, my program will not be compiled. See, it's saying that it doesn't know what is scanner, so I need to import it. Alt enter, import class, import Java to scanner, and now it will run. But it will do nothing because it's unfinished. So what next I can do is just reading an integer. Int size equals to scanner dot nextInt. Please read the next integer, or this scanner is better name. Okay, please read the next input and print something like area equals to size multiplied by size. Because the multiplication has higher priority to addition, to concatenation, first this will be calculated, then it will be here. But it's better to use just int area equals to this and print the area. See, this makes the code more readable, more obvious what it does work, what it does. Okay, so let's run this program and print 5. The area is 25. It reads int nextInt, returns, if I click with this, it returns int. I use the control and the mouse pointer and it says that it returns int. Okay, if I use string here, it will say, oh, string and int are incompatible types. You should do a conversion. So another way is to do a conversion. Integer.parse integer.parse int of scanner.nextWine. Please read the entire next line, and the thing you have read, please parse it to int. This integer.parseInt, this takes as an input a string and returns the integer representation of this string. So if I put here 55, it will be parsed like this. But if I put something invalid like this, it says, oh, I cannot take this as an input. This input string is number format exception. Another thing which can happen is to overflow the integer. It says, oh, I cannot put this into a variable of integer. It's a kind of overflow, but it doesn't explain what's exactly the problem. Or if I put 3.5, it's still number format exception because it cannot be converted to int. If I use as scanner.nextInt, it will behave similarly. If I put correct int like 20, the error is 400. But if I put incorrect string, it says, oh, input mishmash, I have read something which is not what I did. But if I put 20 space 30, it will read the first integer. So nextInt reads the next integer. If I call it twice, it will read 20 followed by 30. For example, if I have size A and size B, two sides of certain rectangle, for example, I can read something like 20 and 30, and the array is 600. So it just reads the next, or I can put something like 20 space 30. This nextInt reads one or multiple lines until it finds an integer. And if it finds something which is not integer, like 20, hello, 30, it will fail. It will read 20, then it will take the next token, the next word, let's say, we'll try to read it as integer, it's input mishmash exception, and we'll stop the program. In Java, when something wrong happens in your program, it gives you an error, it gives you an exception. Later we will learn how we can catch this exception and do some different action to handle this exception, but currently we assume that incorrect input just stops the program. Okay, let's go ahead and learn how to read floating point numbers. Floating point numbers are numbers which hold an integer part and fractional part, like 3.14. Okay, so they are read by the type. They are stored in a type called double, or double precision floating point number, and they use parse double to be converted from string, it's with capital in Java, to double. And this console scanner.nextLine, this always returns string or text, and this text is converted to double, then it's stored in this variable number. Okay, alternative and easier way to read double numbers is scanner.nextDouble. Scanner.nextDouble just scans for the next token from the input, takes it and parses it to, or converts it to double. This is an example we want to create a program which converts from inches to centimeters. Like we know, 1 inch, 1 inch, 1 inch is equal to 2.54 centimeters. This is by design. This is the way inch works. Okay, so this is a way to read the inches from the console, and this is the formula to convert it, and this is the statement which calculates inches multiplied by 2.54 and stores the result into centimeters, into this new variable, and finally it prints this variable centimeters. Okay, I will write this. I will create a new program, new Java class. Programs in Java are stored in one or several classes together. Okay, it will be inches to centimeters, or it might be inches to centimeters converter, because this is a converter, or just inches to centimeters is also a good name. The name should not be too long, because it's hard to read if it takes the entire screen, for example. So it will be, we'll start with scanner equals to new scanner of system.in. Okay, and later, see, it was already imported because I just agreed for the import, and later I say table inches equals to scanner.next table. Okay, and I say var, for example, centimeters equals to inches multiplied by 2.54. I can use var, which is the same like double. It says please calculate this and use the same type like this expression. It might be var. It's better to use double, but just to show you that another way. And these are the centimeters. I can print something like centimeters was this. Okay, I run this. If I click this, see, it will run the square area calculator. It will run this file. So I need to say, please run this one, inches to centimeters. And it will be run. 5 inches are 12.7 centimeters. Looks like it's working correctly. And if I want to format with 2 digits after the decimal point, what should I print is %f to, it's something, %point to f, and it should be printf with /n, and this should be as a second argument to this printf. Let me check. 5 inches are 12.70 centimeters. Works correctly, and this was the example. The other way to use this is to have double dot parse, but it's double with capital. This is the class holding double numbers in Java of scanner dot next double dot next line. See, next line returns string. Next long returns long, etc, etc, etc. So I will use next line, control space. Okay, next line. So let me check whether this works. 3.5 works correctly. I need to mention something important here, and it is that the dot, this point, is not the default decimal number separator for some countries. Currently, I live in Bulgaria, and in Bulgaria, it's assumed that 3.5 should be written like this: 3,5. For example, 3,5 liters of water, for example. Is the way it's correct in Bulgaria. This is called locale specific formatting. So in Windows we have formats. Let me see the current date and time formats. If I open, I have the country of Bulgaria, but I use the English formats. And these English formats use different, for example, I use the Gregorian calendar. The first days of week is Monday, in some countries it's Sunday. This is the date format, etc, etc, etc. So if I use regional format, I can use this. No, change data format. It's not this, sorry. Region settings. Here I can change these additional settings and change the decimal symbol. For example, if I choose the Bulgarian default format, Bulgaria. Where is Bulgaria? Like this. Apply. Now, if I run again this program and enter 3.5, it says 8.88 centimeters. So I can input something like 3,5. Oh, the scanner reads something. Oh, it's a big system in double door parse. Double always uses this, but if I say scanner dot next double, see, it should be 3,5 and the centimeters. This is in Bulgaria, the default. If I put 3.5, it says, oh, incorrect. Why? Because I use this Bulgaria. So I prefer to have the United States, where is it? It should be English. English United States. Oh, okay. And then I will use then, month and year for the dates. The first days of the week is Monday, and additionally it's by default the dot, the comma format, and I don't use groups for digits, I use space. Digit grouping is with space, but measurements are metric. So I changed my format, and now if I run again, it will be 3.5. So in short, if 3.5 doesn't work for double parse, for scanner.next double, just go and change your format here, because it's here, the decimal symbol. It should be dot. It's recommended to be dot because this is the most widely used internationally. Okay, so let's go ahead with the next assignment. We need to write a program called greeting, which reads input from the user, his name, and says hello and his name. For example, if we enter John as an input, the corresponding or respective output will be hello John. If we print put Dave, it will be hello Dave. So I will create a new file called new Java class greeting, by name. This is the name I give for my program, which answers what's inside. It's a code, a Java program, which reads a name and puts a greeting by name. So it will be something like double. No, it's not double. It's a scanner. Scan equals to new scanner of system.in, semicolon, and then string name equals, but it's with large S, so with capital S. String name is scan.read scan dot next line. I cannot type in my keyboard, and it will say something like s out, system out, print system out, println. Why? What it wants? S out. Something gets broken, but I can type system.out dot println of name, or something like hello plus name, and I can, something happens. I don't know why, but something happens. Maybe I have, oh, what happens is that I don't have the main method. Oh, okay, now everything will work correctly. And I can use now s out, enter your name. It will be print without ln in order to enter your name on the same line, not on the next line. And I need to run this, run. I will stop this in just 2 centimeters. Terminate, and greeting by name. I will run it. Run. Enter your name. My name is Svetlin Nakov. It says, hello, Svetlin Nakov. And maybe it will need something like exclamation mark at the end. What's your name? I'm Peter. Hello, Peter. It might be like this. Print f with hello %s and /n, new line, and name. Let me check. Enter your name. My name is, for example, Maria Stewart. For example, hello, Maria Stewart. This is how it works. And this is another solution. We read the name with console next line. We print hello. The cursor stays at the same line. We print the name. And this works in a similar way like our examples. The second variant is to use hello plus name. And the third is with this %s here and comma name. Okay. Let's go ahead. This is the concatenation, or putting together one followed by another, called concatenation. So this is another example of concatenation, concatenating text and numbers. If we have 3 variables, first name holding John, last name holding Doe, and age holding 34, we can combine them or concatenate them using the plus sign. This is not addition. This is not add one number to another. This is concatenation. So it combines several pieces together in a single string, and the result is string. For example, this is the John concatenated with space, then with Doe with space and vertical line and another space, then with the age. This is another way to do it. A plus B is equal to A plus B. This is very interesting. This is string. This is A. This is B. So if A is 5 and B is 11, it will be, the result will be something like A plus B equals to 5, 11. Why? Because this is string. The string plus A is A plus B5. And together this string with B is A plus B equals 5, 11. So this is not plus. This is not sum or addition. This is not. It is concatenation. The same symbol plus, the same operator plus, can be used to combine strings and to sum. If you want to achieve here 16, we should put brackets. If we put brackets, A and B will be first added and then printed. I will show you this. But let me show you first the first example. I don't want to type it from the 0. So it's John Doe 34. John plus space plus Doe plus this plus H. And the result, oh, it's not greeting by name. Sorry, it should be put here, for example, because I want to keep my greeting by name file holding the solution of the problem called greeting by name, and this is the output. I can print something very similar like this. John Doe of H %D, first name, last name, H. Okay, but it should not be println, it should be printf with a new line at the end. So this will print the same thing. If I want to assign this in a result, see like this, string.result, result again, should be something like string.format. I give the formatting string like this one and the arguments. This is another way to use this. And finally, I print this result again. I can either use printf or println combined with string.format. There is no good way to combine variables with text, like variable interpolation in JavaScript, in C#, in Python. Java is the last language still not supporting variable interpolation, or a good way to do this in a better way. But that's life. Not everything is ideal. The second example is this 5 and 11 and how this is combined. I'll show you this example. Int A is 5, int B is 11. Please print A plus B equals 2, then print A, then print B, and this will print 511. If I want to sum this, I can do it like this with brackets, which will change the priority of execution and will first evaluate this, or better, in sum is equals to A plus B, and I just print the sum. And this is a better solution, which is also correct. A plus B is 16. Just be careful about this plus. Sometimes it's sum of two numbers, sometimes it's a concatenation of two strings. And if the second is not string, it will be turned into string before concatenation. Okay, the next topic is about arithmetic operators. I already have partially shown you how to use plus or division, but now we'll talk about add, subtract, multiply, and dividing numbers. using plus, minus, asterisk, and this slash operators in Java. So adding and subtracting numbers is done by plus. It's a plus b is 12. Subtracting 15 minus 7 is 8. It's very simple. So a plus b is obviously yes, I will rename it Control RR result. It's not Control R, is refactor rename, Shift F6. It will be called result because now it's the sum, 5 plus 11, but if I use minus, it's the difference, and the difference will be minus 6. Okay, it's just like it should work. More interesting are multiplying and division. Why? I'll show you first multiplying. A multiplied by b, 5 multiplied by 6 is 30. Let's see what happens if the numbers are big. It gives just incorrect result. Why? Because of overflow. You should use long here, not int, because long fits bigger numbers. It's still incorrect. It should be like this, but it's complex to explain. You should just use long. Now the result is correct. It's called type conversion, because multiplying ints returns int, but if the result cannot fit in int, it's truncated. It's better just to use long and to be able to use bigger numbers like this. Here, this works correctly. But we will talk about overflows later. Just for now, just imagine that overflow exists. And int is ranged from minus 2 billions to 2 billions. And long has significantly higher range. It's twice as more digits as which can fit in int. Okay, division. If you divide two numbers like 25 by 4, if you divide them int, the result will be int, and the remainder will be just removed. So if we divide 24 by 4, the result should be 6. If we divide 25 by 4, it should be 5, but because this is integer division, it will be just 6 again. Okay, this is how this works. It takes the decimal, only the non-fractional point, the whole, the integral point, part of the result. Okay, so when dividing integer, the result is also integer, like this. 25 by 4, it's 6. But if we divide by 0, it will be an error. See, a runtime error. If b is 0, and we divide 25 by 0, it's arithmetic exception, division by 0. It's error in our program. But if we divide by 4.0, which is double, the result will also be double and will be 6.25. See? When we divide two numbers and one of them is double, the result is double. The result is fractional. The result is non-integer. If both of them are integer, the result is integer. And the interesting thing is that when we divide something by 0 in double, the result is infinity, which is obvious, but infinity is a special number which is just infinite number, infinitely big number. Okay, I will not get into details. This is just how this works. And finally, if you divide 0 by 0, it will be undefined or not a number. None, not a number, undefined, because it's undefined by math. So that's the processor doesn't know what to do. So 15 divided by 2.0 is 7.5. By 0 it's infinity, and 0 by 0 it's not a number. This is something I already demonstrated to you in the latest example. The interesting operator next is this percent. Percent or percentage is the module from integer division. It's the remainder from the integer division. For example, if you have 7 divided by 2, okay, 7 divided by 2, this is 3.5. But 7 divided by 2 as integer is 7 and remainder 1. Do you agree? It's because 7 multiplied by 2, it's not 7 remainder 1, it's 3 with remainder 1, sorry, because 3 multiplied by 2 is 6, plus 1 remainder, it's 7. This is how this works. So this is just the remainder. A% B here is 1. It is the, when you divide and when you remove the the integer part, there is a fractional part. And this fractional part before the division, it's called remainder. So it's something like this. A% P is the int part of A divided by B multiplied by P, and this is, sorry, A minus, for example, 7 minus 6, because 7 divided by 2, this is 6, and the remainder is the original A, 7 minus this 6, it is 1. It is the remainder. It's a math concept, so I cannot explain it better than the mathematicians, so it should be you should be familiar from this, from the school math lessons. So 7 is 3 times 3 multiplied by 2 plus 1. It's 2 is the division result and 1 is the remainder. Similarly, 3% 2 is 1. 4% 2 is 0, because 4 is directly divided by 2 without a remainder. The remainder is 0. And 3.5% 1, this is the fractional part. This is a standard way, percent 1, to take the fractional part of non-integer number, of real number. Okay? So, of course, you cannot, I will show you this, you cannot divide by 0 and have percent 0. So int A is 20, for example. A% 5 should be 0, because it's 5 multiplied by 4 is 20. The remainder here is 0. I'll show you. But A% 3 is 2, because 5 by it's not 5. 3 by 6 is 18. Plus 2 is 20. So the remainder is 20, because 20 by 3 will be 6. But we have plus 2 as remainder. Now the remainder here is 2. Okay, so interesting scenario is when we have a number like this and we want to take its last digit, this 3. I should print %10. %10 takes the last digit of given number. Okay, %100 takes the last 2 digits, 43 here. See? So this is very helpful property. And if we want to divide by %0, it will return 0. It will return a problem. Division by 0. It doesn't work. So don't use it. And also if we have -20, the remainder will also be negative. This is how it's defined by math. -2 is the remainder here. Okay, so this is how this works. %1 gives the fractional part of given number. That was all about this plus, minus, multiply and divide operators. Now let's say a few words about expressions. Expressions are the mathematical and natural mathematical way to combine values with operators. So this thing is called an expression. But I can make even more complex expression, plus 5, for example. Or I can say 2 times this plus 5. That is this. And this is an expression which will be calculated and a value will be returned. So this is something very natural. Expressions combine operators, literals and variables which are related to a value. What is the word literal? Literal is a way to express certain value in your program. So this is a integer literal, -20. Or -20, this is also a literal. Let me show you. 000 underscore 000. This is the value of 2 millions. 2 millions, but written in a more readable way. Or it may be int b equals to 0x55. This is a literal which says that the value is in the hexadecimal system. This is a value which is separated by underscores. They are ignored. Int c is equals to 0b, and this is a binary literal. I don't know the value. So we can calculate a plus b plus c, and this is an expression, plus the literal 0b 11. And the combination of values or literals with variables, with other operators, with brackets, for example, something like this, this is called expression. So this is how we can organize more complex computations. The result is this. You can check it yourself. So this is expression, consists of at least one operand, which is a literal or a value or a variable, and can have one or more operators, just like this. X plus 5 is an expression. This, the assignment, is also an expression. So let me show you. Like we can print this, we can print if we have int sum, I can print sum equals to a plus b plus c. And this is correct because sum, this equals, this expression returns the right part. So I can say sum is equals to this, and the result will be this, and also the sum will be assigned. So this is a combination of assignment plus returning the result from certain expression. This will print the same things here. Okay, this is another expression. This is called string expression. So the type of the result here is int. But if I do something like text plus a plus b plus c, this will be expression of kind string. So I can print some text combined with this, and this can be summed before combining. So this is an expression of type string, the result of this computation. So expression is a computation. It's string. See the result. This is the result. Okay, and we can have more complex expressions like this. We use brackets when we want to change the order of execution for the calculation of this expression, like in math. And like in math, the multiplication and division have bigger priority than the others. So something like 1 plus 3 multiplied by 4, 1 plus 2 multiplied by 3 is 6 plus 1, this will be 7. Okay, but if we change the order, 1 plus 2 will be 3 multiplied by 3, like in math, this will be 9. So the same rules like in math for the priority are applied here in programming when we calculate numeric expression. Okay, a lot of things I have given for you today. Working with the console, reading input, reading output, working with int, double, string, using different kind of data types, reading values, printing values, formatting values with placeholder, %s, %d, %f, %.2f, things like that. Now it's your time to play with this concept through the practical coding exercises. You will find these exercises in your online lessons, in your learning platform, and please start coding, because learning of development, software engineering, coding is done only by practice coding. So please code now or later. If you don't code, you are nothing. Just like if you watch someone driving a car, it's not like you to try driving a car. Learning coding is about practicing. Start now, and after a while I will come back and I will show you my solutions to these problems. But first, make your best to solve them yourself. If you have questions, you can ask in the chat and we will answer you, because this is our job, to help you, to assist you, to support you during your learning process. So start. Hello again. Did you solve your problems? Now I will show you my way to solve these coding exercises, and I hope that you will learn some better way of doing them, or some of them might have solved them in a better way than me. You'll see. So the first problem is called calculate speed. It's about writing a problem to calculate the speed by time and distance. We are given time and to a given distance. For example, for 10 minutes, I have run 3 kilometers. What is my speed? If I have the distance and the time, if I divide the distance by the time, I will get the speed. So it's about calculating the speed needed to travel given distance for given time. I need to print the result formatted to the second digit. This is an example. If I have passed 15 kilometers for 2 minutes, my speed is 7.50 kilometers per minute. Whether the first is kilometer or inch or mile, and whether the second is second or minute or hour, it doesn't matter. It's just about to divide two numbers. So it's called speed calculation. I will open IntelliJ IDEA and we'll create a new Java class what will be called speed calculator. What's this? This is a calculator for speeds. Okay, I'll put the main method and I will write here something like scanner equals to new scanner of system.in. Okay, I need to put out enter here to import the class. This created this new line, and now I can read first what's given first. First it's given the distance, then the time. So double distance equal to scanner dot next double. Okay, I will read additionally the time. Double time equals to scanner dot next double, and I will calculate the speed. Double speed equals to distance divided by the time, and I will print it's sout CW. This is in Visual Studio in C#. It's something like speed equals, and I will print the speed. Let me check if I have, oh, not this, run this. Control F5 runs the last problem, the last Java file I have already run, but this is my first run for this class, so I need to run it explicitly. I say something like I have passed 70 kilometers for 3 hours. I should pass 23.333 kilometers per hour. If I run, for example, 20 kilometers for 2 hours, my speed is 10 or 10.0. I can print %.f2 because by design I need to format the result to the second digit after the decimal point. So it should be something like this. But if I run this incorrectly, I'll show you, 25, this percentage is printed. I should use print f, not print ln, and new line, in order this percentage to be used and replace it with this argument. Okay, and now it should work like expected. If I 21 for 4 hours, point, it's not point f2, it's point 2f. Let me test again. I had a bug in the program. 21 for 4 hours. My speed should be 5.25. For 4 hours it gives 21. I believe this program is solved. Let me see the already prepared solution. I create a scanner, I read the distance by parsing the next line to double. I read the time by parsing the next one coming from the input into a double number. Then I divide the distance by time and I print formatted the speed. Okay, the next program, the next assignment is to write a program which converts from US dollars to euro. Assuming that the dollars come as a floating point number, and the rate between dollars and euro is 0.88 euros for $1. This is, we assume the rate is flat. It's not true, but for simplicity. And finally, we print the converted euro value formatted to the second digit. So 17 euros are 96 dollars, euro, sorry. $87 is 76.56 euro. Okay, let's do it. New Java class, and I say dollars to euro converter. This is what I have in this program, dollars to euro converter. I have the main method, and in it I have scanner equals to new scanner of system.in. It was imported when I press enter. This should be small letter, and I have something like enter USD amount and double US dollars value equals to scanner dot next double without a n, and print. First calculate the euro value equals to US dollars value multiplied by 0.88, because this is what the problem statement says. And now it will print something. You have %t euro, something like this, and the euro value. But it needs printf with /n. Let me check whether this runs correctly. I will run this program by right-clicking over the code and saying run. $20 are t is not double, because this is an integer, %d. It should be %.2f. Let me try again. I use %d, which is for integers, and I put a double value, so it doesn't work. $20 is 70.60 euro. Looks correct. So 17 should be 14.96. Let me check for 17, 14.96. Works correctly. Let's go ahead with the next problem. First, the solution is very similar. We read the first double, we multiply by 0.88, and we convert the output formatted to 2 digits after the decimal point. The next problem is called area of triangle. It's about calculating the triangle area by given side A and the height for that side called HA. So we have side and height. If we remember the formula for triangle area from school, we can calculate the area just by multiplying the side by height and dividing by 2. We need the area formatted to the second digit after the decimal point. If we have 5 by 10, it's 25.00. If we have 3 by 10, it's 15.00. So area of triangle, I will copy this because I will need it. I will create a new class called triangle area, for example, or triangle area calculator. I'll use the main. Then I have this. Then I have double size. I just used this from the clipboard. Equals to scanner dot next double. I have the size. I will copy this line and hide. I read them and I print with printf some value percent point to f, and this will be the area, and the area will be double area equals to size multiplied by height divided to 2.0, or divided by 2. It will be the same in both cases. Some of the arguments of this division are of type double, so the result will be double. It will be double of division. Let me check whether this works. It doesn't work like I expected, because area, it was just printed by mistake, and I don't need area. Now it's correct. So I run this and let me check whether it works correctly. 5, 4, 10.00, 3.40, 3.55, 3.75. It's something like this. This is how this works. This is the area, triangle area calculator. The solution here is very similar. It's the first solution to have the area here, or a shorter solution, but less recommended to have this here. Why the second solution is less recommended? Because it's more hard, it's more complex to understand what happens. It's obvious here that we calculate the area. It's obvious. It's obvious here that we print the area. But it's not very obvious what exactly we print and what exactly we calculate, because we don't have a variable called area, which explains that this is the area and this area is calculated by some formula, things like that. So the first solution is highly recommended to the second, because the second is more complex. It's shorter, but it's more complex, and this is not good. Good developers, strong developers, best developers write simple code. Bad developers, they think they are very clever and they write complex code, and after a few months they cannot read their code as well. They cannot themselves read their code. So don't write complex code. Use good variable names, use good class names, use simple sequences of commands, simple statements, not complex expressions. This is recommendations from the experts, and good developers know this very well. The next problem is called for operations. It just reads two numbers and print their sum, their difference, their multiplication, and their division, like this. If you have 5 and 10, we print 5.00 plus 10.00 equals 15.00. Okay, I will take these two lines, I will need them, and we'll say, please, for operations, please create this class, put in it the main method, use this, import the Java util scanners, I use the clipboard, and I'll have first and I'll have the second input, and I will print something like the first percent point to f plus the second equals to third, and we have this first, this second, and this first plus second. Let me check whether this works. Oh, it should be printf, not println, with the new line here. Let me check whether this works. Okay, 7 plus 5 should be 12. 7 plus 5 is 12. Okay, the others are exactly the same. I copy this 4 times and say minus multiplication and here I have division and division. And let's check what happens. If I have 7.5 and 2, I have 9.5 books correctly. So I'm ready with this problem. This is the solution which was prepared, num1 and num2, and it's even nearly the same. So %n means new line, and /n also means new line. Sometimes it might have differences, but let's not get into these details. So I already have shown my solution, so let's go ahead with the next problem. The next problem is called days to minutes. I want to write a program which reads a number of days and tells me how many minutes are these days. For example, 5 days might be, this is an example, 2 days is 2,880 minutes. I read an integer and I print the minutes, which is another integer. 5 days is 7,200 minutes. Okay, days to minutes. I create a new project here, a new Java file. Days to minutes. It's recommended that you have one project per each lesson. For example, in our training course called Programming Basics, we have several lessons. Intro to Programming was the first lesson. Calculations examples is the second lesson. The next lesson will be conditional statements. And for each problem, we solve many problems. You should have one Java file. This is a good way to structure it and also have a good names, readable names. For example, what is square area calculator? It's something which converts from inches to centimeters, or something which prints a triangle of stars? No, it's clear what is it. It's something which calculates the area of given square. So let's continue with the days to minutes. I have main. I have in the clipboard, not the correct thing, but I will go here to take this line of code and I will return back here because I don't like to enter this code so much times. Next I will read the days. Int days count equals to scanner dot next integer. Next integer. Okay. Then I will say how many hours hold these days. And hours equal to days. Each day has 24 hours. And how many minutes are there? Each minute, each hour holds how many minutes? Exactly 60. This is how our clock works. So if I print the minutes, there will be something like this. Let me check whether this works. I run and I say that I have 5 days, and in 5 days I have 7,200 minutes. It's like this. So I assume it's correct. I read the days, I multiply by 24 and obtain the hours. I multiply it by 60 and obtain the minutes. And finally I print the minutes. Very simple program with 4 lines of codes, with 4 statements, 4 commands. I can print it like this. Another solution is to be something like, let me take the calculator, 24 by 60. This is also a valid solution, but it's a bad solution. It's an unreadable solution. It's correct, but it's bad. Why? Because what's this? Why it's not 1740? What's this? You are unable to know what's this. So the best way to do this is like this. to have different steps. The first step is to read. What I read? I read the number of days. What next I do? I calculate the hours for these days. What next I do? I calculate the minutes for these hours. What's next? What I do? The next thing is to print. So please, when you write code, write it like this, with a long number of small steps, small, obvious, understandable, readable steps, simple steps, instead of small number, complex steps. This is disaster. Don't do it. Okay? The next problem is called circle and area and perimeter calculator. You are given the radius of a circle, floating point number, a double number, and you need to calculate and print the area and perimeter of the circle formatted to the second digit. This is an example. If we have 7, the area is 153.94. If we have the perimeter 43.98. Okay. Circle, area, and perimeter. It's obvious how to name this new Java class. Circle, area, and perimeter. This is what's inside. What's inside this program, this file? It's something which works or calculates circle, area, and perimeter. Perimeter. Shift F6. I have bug. Perimeter without DC. I should delete DC. Delete, enter. So here it was changed. Here it was changed as well. This is what to do when you have mistake, when you have bug. Main. And now what I have, I'll take these 2 lines of code here. And I have double radius dot next double, and next I will do the calculations. Double area is equals to p by radius PR square. This is the formula for circle area. If you don't believe, just open a web browser like this, for example. Here, perimeter formulas. Circle area and perimeter formulas. And this, if this is the radius, the area is P by R by R, and the perimeter is 2 by P by R. And what is P? What is P? P is this constant. This P. If you have never been in school, it will be complex for you, but I suppose you have been there. Okay, so how to get this P? We can just take it from here, Control C, Control V, and double perimeter is 2 by P by the radius. Finally, I can print area equals area and perimeter equals perimeter. Run this program, and I have a sample data here. Wait, where is 7? Okay, if it is, I told you to run this program, what happens? 7, 1.3. Oh, I should have this %.f, %.f /n and print f instead of print ln with a comma. This is how this works. Run it again, and now I have 7 radius 153.94 43.98. Okay, but this is ugly. This is something I need to remember. If you do another search on internet like P in Java, you'll find how to use P in Java, and it is something like, do you see? math.p. Let me try. math.p. Looks like Java knows, has math.p, and Java knows how much is the value of p. So I just put it, run it, and if I enter 7, the result should be exactly the same. It is, this was entered by me by mistake. Okay, so this is a better solution. Let's see what I have had in mind before starting to solve these problems. Exactly the same thing. I read the radius, I calculate the area by multiplying math by p by the radius again, and this math p constant is this one. It's already known by Java, I don't need to remember it. The perimeter is the other formula, 2 times p pi over the radius, and I print again. Yes, looks correct. Here I use this %n for the new line, or it might be /n, but this is these are details. Okay, the next problem is called person info. It's about writing a program which reads info about a person and prints this info in a structured way, like it reads the first name, the last name, the country, and the town, 4 strings. Okay, and prints in this format. This is the example: Kelly Smith from Ireland, Cork, or Svetlin Nakul from Sofia, Bulgaria. I will write this person info. Add new class. This is person info. I will use Control Tab to take this line. Will return back main. I will increase the font in order to simplify you when reading and watching the video. Okay, and next I will say something like, what is it? First name, string, first name equals the scanner dot what? But next line. Please read the next line. First name. I will copy and paste this several times. Last name, first name, last name, then country, then town, and I need soutf, solve is printf /n. It's something like Peter Clark from %n Sofia, from country dash town, and I print the first name, last name, then country, then town. Enter. Let me check this. I'll take this Kelly Smith, paste. It's pause. It's not paste. Control V, paste. Input mishmash. Next line, next line, next line, next line. Maybe I need to write this because copy paste doesn't work. Svetlin Nakul. Oh no, it doesn't work. First name, input mishmash. Why? At which line? Ha! Next double. I'm running different problem. So it should be person info. Run this. So I was testing different problem. Kelly Smith for iron cork. I don't have this exclamation mark at the end. Let me test again. I fixed this bug. It started, Control V, Kelly Smith for iron cork. Works correctly. So I have the solution, and this is another way, which is exactly the same, exactly my solution. So the next problem is called town info. It's very similar. It reads name, population, and area. 2 integers and 1 string. And it says the town of town name has population of population name and area of area square kilometers. Just like this, town info. It's very, very similar. I will take this. I can copy this file. See, I take this file, Control C, Control V, and I will use town info. It's not, sorry, it's not person info, it's what? Town info, it's correct. So I created a copy of my previous program. It's called town info. It reads name, population, area. Name, 10 int population. And if I say next int here, I might get into trouble, but let me check. Area, next int, and I print something like the town Berlin has, oh, I can do this. It's easier. The town Berlin has, copying from PowerPoint doesn't work well. The town as, which is name, Shift F6 is town name, in fact, population of %t and area %t area, and this is what I have, and I don't need double slash n. Let me check, run, and I will print this as input. Control V. Berlin has this population, this square kilometers. Works correctly, so it works. But if it is like this, first the population, area, and then the town name, it will not run. We'll see. For example, this is the population, the area is this, and the town, do you see? It doesn't work because this is the problem. Scanner next line fails if you use next in and next in. In short, you cannot read string after int using the scanner unless you use only next line and integer dot parseInt. If you use this approach, it will work all the time, but it's more complex and more long for writing. So if we have this population with this area, the town of Sofia, for example, works correct. So please be careful, and this is our solution. Okay, let's go back here. This is an example how to read the population, area, and the town name, and how to print the required output. So this was our WASP problem, and I'm happy that today I have shown to you how to use variables. You already know that variables hold some data in the memories. Variables have data type, which defines their data range. For example, integers from -2 billions to 2 billions, this is the type int. Bool is the type which holds either true or false. Local date is the type which holds a date. String is a type which holds text string. Statements define commands, like assignment statement, like method invocation statement, like object.actions, brackets, some parameters, and things like that. We have written many statements. Developers write statements. This is their jobs, software engineers or coders. Reading inputs in Java is done through the JavaUtil scanner class. You write Java scanner scan equals to new scanner brackets system.in. Later you say next int, next double, next line. We know simple operations like plus, minus, multiply, divide, percentage, which is a reminder calculation, reminder of the division. And we know that we can combine this into expressions, and we can format to 2 digits after the decimal points using this %2f. And we know that expressions combine data plus operators. This is what we have learned, but this is the theory. The practice is learned only one way. Solve your problems. Please solve the problems that even if I have shown you the solution, code it yourself. It should run in your hands. Otherwise, you'll never become a developer. Developers write a lot of code every day. Hundreds and even thousands of lines of codes every day for years until they reach a beginner level and start a job in the software industry. And after that, they continue to do this for many years and to enjoy their good, nice, modern job, which brings them a good standard of living. In this section, I will explain and demonstrate how to write simple if-else statements in Java. Conditional statements, like the if-else statement and few other statements in Java, check some condition, and if it is true, they execute certain block of code. Otherwise, they execute another block of code. We shall see how they work in practice, and after that, as usually, you'll have homework assignments. You have several hands-on exercises related to reading some data, performing a check, and printing a result depending on the input data and the checks. Are you ready to learn the if-else statement? Keep watching and write your exercises at the end. And we are ready now to go to the conditional statements lesson, and I will start with a small introduction. So in the real life, we may have a garden and where plants are located, and sometimes we need to water them. So, but if it is raining, I don't need to water the plants in the garden because there is rain already. But if it is not raining, otherwise I will have to water them. So in case it is raining, I will do nothing. Otherwise, if it is sunny, for example, I will need to water the plants. So if you want to automate our watering system in our garden, we may have something like this. We may need some sensor which checks the humidity with some controller, and this controller or this small chip which controls the watering system will check the humidity. If it is greater than 90%, it looks like it's rainy and we don't need to switch on the watering system. Otherwise, or else, we need to water the plants. So we just say, please water plug.enable or switch on, and it will run the water in the garden to plant the plants, to water the plants. So this is how in the real world scenario
we may need to check a condition and take some actions according to this condition. If it is true, we do something. If it is not true, we do something else, another thing. And this is in the real world. In programming, we have the same concept. The concept which I will explain you a little bit later. So let's first start with the logical expressions. Logical expressions are expressions which usually involve the comparison operators to check some condition, and this condition is used to take action according to its value. I will show you how, but first let's see equal2. This is the operator equal, which checks whether two values are the same, are equal. Not equal is this exclamation equal. Greater than is this, greater than or equal is this operator, less than is this operator, and less than or equal to is this operator. This is how they work. In programming, we can compare values using these comparison operators. We can compare values like numbers or some other types which allow comparison, but in Java, we can compare mostly numbers because these operators don't work for strings, for text, for dates, for example. The result of the logical expression is either true or false, and this is an example. We have an int value a equals to 5, int value b, variable b equals to 10, and if we say please print whether a is smaller than b, this will print true. If we print if a is bigger than 100, it will be false because a is 5. 5 is not bigger than 100. If we check whether a is less than or equal to 5, 5 is less than or equal to 5 because 5 is equal to 5, and the result will be true. If we have please calculate whether b is equal to 2 times a, we multiply a by 2, which is 5 multiplied by 2 will be 10, and we compare 10 with b, which is 10, so this will be true. And finally, we check the opposite comparison, whether b, 10, is different than 2 times a, which is also 10, and this is false because they are equal, they are not different. So let me show you this within the Java IDE. I will start this. Oh, I have started already this IntelliJ IDEA. You know, this is our IDE, integrated development environment, and here I have the project from the previous lesson. I will create a new project, which will be named conditional statements Java. I had this from other lesson from C#. Okay, it was just a naming conflict. It should be empty. Yes, it is, and this in src source directory we have this. So this is our class, and here I can demonstrate you how to use these logical expressions. For example, I can print out print whether 5 is equal to 5. If I run this, run main, I'll get something like it should be true. It takes some time, but generally the result is true because this is true. We may have something like int a is 5. Please check whether a is 5. And run this. It will say, it says, oh, it takes a lot of time. IntelliJ IDEA is really slow, but that's why. So next I can say int b equals 10. Please s out. Please print whether a is equal to b, and it will say that it's not true. It will say false. Okay, and I can say please whether they are different. It will say true. I press Ctrl F5 and it says true. I can check whether a is less than or equal than b, and it will say Yes, it's true, because 5 is less than or equal to 10. But I cannot check whether this, because this is string. I cannot compare string, see? I cannot compare int with string. So this will not work. And also, this operator cannot work for strings. Whether A is less than Peter or Mariah, this doesn't work in Java. This works very well in other language like JavaScript, but it doesn't work in Java. So, but we can do this using some other things like string dot compare. Oh, it should be something like Mariah dot compare to Peter, and it will say maybe 1 or -1. It's -3, which means that Mariah is after Peter. But if they are the same, it will print 0, which means equals. But we will learn about string processing later. I just wanted to show you that we have comparison operators, and when we compare values using these comparison operators, we can build conditional statements and conditional expressions like this one. This is called a comparison expression or conditional expression, and this expression is either true or false. We can use these expressions later to build if-else statements. I'll show you how. But let's mention a little bit the string comparison. If we want to compare strings, we should use the so-called equals. Please, the first string dot equals the second string. I'll show you how. So if we have string A is example and string B is also example, we can compare them by checking A dot compare to B, and it will run correctly. It will say true. No, not compared to, I'm sorry, equals. Compared to will also work, but you should check for 0. This will say true. So if we use this one, it's incorrect. Never do this in Java. No, don't do this. This is bug. It doesn't work. It just checks whether the address of the variable A in the memory is the same like the address of the variable B in the memory. It checks whether these variables are the same variable, which is something completely different than checking the value. I'll show you why this doesn't work. It might work. It will show true now, but it's by chance. It's because of the compiler optimization. But generally this doesn't work, and I will show you. If I have this dot sub string of 1, okay, so I can print that A is plus A plus slash n and B is plus B. Now I will show you that A and B are the same strings. See, A is example, B is example. The equals is false, so this doesn't work correctly, and true here. So it's proven that this is bug. Don't do this in Java. And also IntelliJ IDEA says that string values compared with this are not okay. This says that this will be always true because it's a kind of, it has some kind of optimization. But generally we may have incorrect results if we use equal for strings. In Java, this doesn't work. It works very well in all other modern languages like JavaScript or C# or Python, but it doesn't work in Java. Okay, so let's continue with the core of our lesson today, which is about conditional statements. I'll show you how to use simple conditional statements like check something and if it is correct, do something, do some comments. So we can check certain condition and take action according to the result of this condition. It's something like if some condition is true, please, which is a Boolean expression, please execute this piece of code. So the result of this condition is either true or false, and the code block, this is called code block, this, from the opening curly bracket to the closing curly bracket, this is called code block of code. Okay, this may hold 1, 0 or many commands or actions or statements to be executed. I'll show you how. So assume we have a problem. We want to check whether the temperature of the water is freezing or not. We read the temperature in the Celsius scale and we check whether the temperature is below 0 or not. So we print freezing water if the temperature is equal or smaller than 0, otherwise we print nothing. So if the temperature is 4, we give no output. Otherwise, if the temperature is less than 0, like -2, we print freezing weather. So this is the problem called freezing weather, and I will solve this for you to show you how to use conditional statements in Java in practice. So I will create new Java class, which will be called freezing weather. Okay, and in this class I will create the main method and I will use scanner equals to new scanner. The autocomplete works very well. System.in. Okay, and I will say double temperature. Temperature, it's complex word. Equals to scanner dot please read the next double value. Okay, and now I can do the magic. If the temperature is less than 0 degrees, I will print something like freezing weather exclamation. Otherwise, I will print nothing. So if I run this program, it will read a temperature, for example, 5 degrees, and it prints nothing. I run it again, -2 degrees, it's freezing weather. 0 degrees, it's still not freezing, but -0.5, it's freezing weather. -20, it's very bad freezing weather, Chicago style. -35 is Alaska style freezing weather or Canada style freezing weather. So this is how it works. If do this, otherwise do this. I can run this through the debugger. I will put a breakpoint and will say please debug this here, and the program will stop here. I can press F8 and I will go here and will enter -2, and now it has this line of code. I press F8, it checks the condition. I can track whether this condition is true or false. It says the temperature is -2.0, F8, and see that the code is executed here and the result is correct. So I can print other more commands here, like please take hot take a code, for example. Take your code to dress yourself and be prepared for this freezing weather. I will run it, and now if the temperature is less than 0, I will print these two comments. So it's minus 5.6 degrees. Oh, it's freezing weather, please take a coat. Okay, so this is how this works. It's the same thing which I already demonstrated, written here for simplicity. So if the temperature is less than or equal to 0, I print freezing weather. It's not below 0, it's discussable whether it's equal or less than, but I assume less than is better. Oh, I'll even fix this here. So, but you catch the concept. We put if, we put a Boolean condition in brackets. This is called conditional condition. It might be it's just some check. We open the bracket, we close the bracket, and we put comment, semicolon, say another comment, semicolon, and this is how this works. I already demonstrated this for you, so we can go ahead and learn how to use better these if conditional statements. So we may use if-else conditions, which means if the condition is false, we may execute another code. If the condition is true, we execute something. If the condition is false or otherwise, we execute something else. This is the if-else construction. So we have if some condition. If it is true, we execute this code block of comments. Otherwise or else, we put else, which follows if. This else is for this if. We execute these comments. This is the construction, and I'll show you how to use this. But first, let's discuss the concept of blocks. Curly brackets in Java introduce blocks. Blocks are just groups of comments. So we may have a block, we may have a comment, semicolon, another comment or statement, semicolon, another comment or statement, semicolon, and closing bracket. And this is a kind of statement. So this is something like a comment which internally consists of several other comments. Like, for example, the command open the door may consist of first go to the door, then take the its opening thing and turn it on the right, then pull the door, and many other things. So it's action which consists of several other more simple actions. This is called block, and in case the if statement holds does not have curly bracket, only the code on the next line will be executed. Let me show you what this means. So assume we have a variable called color holding the value red, its string. If the color is red, we execute this statement. Otherwise, we execute this statement. But if we want to execute several statements here, like first, second, third, we'll need to use these brackets. If we have single comment after if or after else, we don't need blocks. Otherwise, we need blocks, and I'll show you how to use this. But in all cases, the comments which follow the if statement starts here and ends here. So this is a statement which consists of if, comment, else, comment. This is the first statement of our program. This is the second statement of our program. This is the third statement or third command. So we have a sequence of three commands. The first assigns a value to a variable. The second is if else, check something and do some actions according to the result. And the final one is always executed and it prints lemon. I'll show you how to use this in Java. I'll open this example and I will use something like string color is red. The color is red, and if the color is red with double quotes, I will print it is red, for example. It should be not equals, this is a bug, equals to red, okay. Otherwise I will print not red. Let me run this. Okay, it's red. If it is yellow, it will be not red. This will be executed. But if I want to put several expressions here, like print it's red and I like red color, this will not work. See, it says, oh, it doesn't work. You need this opening bracket and this bracket, and this is a command. This thing here is a command or statement which holds internally several other statements, these two lines of code. So now it's not red still, and I can print this like if I print this not red, I don't like red, this I don't like red will always be executed. See, not red, I don't like red, but if it is red, it will be red, I like red color, this will be executed, this will be executed, and this also, because else is working with this one also, only this one is for the else, and this one is incorrectly formatted and it follows the if. So the if is completed here, and this is another portion of our program. Even if we format it like this, it works the same way. It's incorrectly formatted code. So if we want to put these both commands together, we need these brackets. Without the bracket, the else works only for this. So this is the finally say goodbye, for example. Okay, so finally say goodbye will be always printed and not depending of the color. Depending of the color, either this block will be executed or this command will be executed. It's not red. So this is how it works, and I'll show you in another example. We have color red. If the color is red, we have blocks of two commands. For example, we print two red things like tomato and strawberry. Otherwise, we print three blocks of commands, like some fruits and vegetables which are not red. So this is how blocks work. They start with this and they end with this, and their content is moved to the right, indented to the right with one tab key. You have TAB tab on your keyboard. It's on the left side. So we have one tab on the right here, and this is the normal formatting, which says that if this is true, these commands will be executed. Otherwise, these three commands will be executed. So you will find that this is very easy once you take some experience. So just for your better, always put this and avoid having else or if blocks without these brackets. It's better to always put brackets. Okay, so we have our next problem to solve for just getting some more experience. It's about writing a program, a Java program, for checking whether a number is odd or even. We read an integer number, and if it is even, we print even. Otherwise, if it is odd, we print odd. This is an example. 4 is even, 7 is odd, and we can do this. Okay, I will take this freezing weather and we'll print Control C, Control V. I want to duplicate this class because I don't want to write the entire program from scratch. Let's get back here. It's something which has a name, it takes some input and does something depending on the input. I will have Control C, Control V, and we'll give a good name. The good name is here, it's called odd or even. Odd or even. So it's class named odd or even. It opens a scanner and it reads, it's not double, it's int num, which is the next int. Reads an integer, and if the integer is odd, num is odd. How to check where a number is odd? Odd numbers have remainder 1 if we divide them by 2. This is the way. %2 equals 1. And we print that this is odd. Otherwise, we print that this is even. Let's run this and check whether it works correctly. So I'll try 5 is odd. Okay, I run this again. 7 is odd, but 20 is even, and 0 is even, and -3 is odd. Oh, it's even. I'm not sure. No, it's incorrect. But this doesn't work for negatives. It should be like this, different than 0. So now -3 is odd, -4 is even. Or it might be if it is 0, it's even, otherwise it's odd. And this is correct. So we have 4, just a moment, 4, it's even, 5 is odd, 5,000 is even, -1 is odd, -50 is even. It works correctly, and this is our solution. So let's get back here. The solution I had in mind before starting this session is just check for division and the remainder. If it is 0, it is even number. It is number which is directly divisible by 2 equal integer parts. Otherwise, it's odd. So it's even or odd. Okay, let's go ahead with the next problem. It's called greater number. It's about writing a program which finds the greater of 2 numbers. So it reads 2 integer numbers and it finds the greater, the bigger of them. It prints greater number, column, and the greater number. Like if we have 5 and 8, the greater is 8. Okay, if we have, for example, 5 and -8, the greater will be 5. Okay, let's solve this. Greater number. It's very similar to odd or even. So I will copy this. Control C, Control V, copy paste. Okay, greater number. and this greater number reads one number, num1, and second number, num2. I copy pasted this one, this line. So if num1 is bigger than num2, which is the bigger number? Num1, which is bigger than num2. So I have greater number and num1. Otherwise, they are either equal or num2 is bigger. So num2 will be the bigger or greater number. I will run this and will demonstrate that it works correctly. So if I have 10 and 20, 20 is the bigger, the second one. If I have 30 and 20, 30 is bigger. If I have -5 and -10, -5 is the bigger number. So this is how this works. It has a check if to something, if this is correct, otherwise to something else. Very simple, but this is how the if-else statement works. This is the way we can solve this problem, and my solution here is very similar to the other solution which I already demonstrated. Okay, so we learned until now how we can check conditions and execute some commands if the condition is true and some other commands if the condition is false. Now we shall learn how to use series of checks or sequences of check, another check, another check, another check, and take different actions according to whether each check is true or false. So we can form more complex conditional statements or more complex programming logic based on sequences of checks. Let's see how this works. It's called series of conditional statements. The if-else statement can be used in a series like this. If some condition, for example, if age is bigger than 100, print you are old. Otherwise, if the age is between 70 and 100, print you are almost old. Otherwise, if the age is between 20 and 70, print your average age. Otherwise, print you're a child. This is just an example. If something is true, run this code. This might be a single line of code or might be some brackets and several lines of code or commands or statements enclosed in this block. Otherwise, check another condition. Otherwise, check another condition. Otherwise, check another condition. So it's true that if this first condition is true, this will be executed and all these checks will not be tested because they are in the else statement, which is normal, which is just the traditional logic we might have if we think a little bit. So this is an example whether we have a series of conditions, but the first condition is true and the others do not execute. So we have a is 7. We check if a is bigger than 4, which is true. We print, oh, it's bigger than 4. Otherwise, we will not get there because a is already bigger than 4. Otherwise, if a is bigger than 5, it prints bigger than 5. Otherwise, it will print it's equal to 7. So here, the output is just bigger than 4. And this and this will never happen because this is true and this is executed. And this is the normal logic you may encounter. So if you want to run this correctly, you may need to first check for bigger than 5 and otherwise bigger than 4. And finally, this. Okay, so just be careful when you build and design your if-else series of conditions to avoid unplanned situations where you check something and the else statement never executes. Okay, this is the next problem we shall solve together. It's called number 1 to 9 as words. It's about writing a program which prints the given number as words. It reads an integer and checks its value. If the integer is in the range from 1 to 9, it's printed as English words, for example, 1 or 7. Okay? If the number is out of range, or for example, it's 100, we print out of range. Here are some examples. We have 7 as a digit, as a number. This is the input, and the output is this text, 7. If we have 10, it's out of range. If we have 7, it's not 7, it's 2. It's a bug in the slides. If we have 2, the output is 2. So this is how this works, number as words. I'll create another program which will be called number as words, a new class. Okay, I'll have here the main method, and in this method I will copy, Control Tab, this scanner and this reading because I need it. Okay, Control C, Control V. I read the number num, and now I can check if the number is 1. I will print 1. Okay, and otherwise, if the number is 2, I'll print 2. Beware of this. This will not compile, but sometimes you may have this as a mistake. Usually it will not compile. Always use double equals to compare values. I'll copy this because I have some similar, like 3 similar conditions. 4, I have 5, I have 6, I have 7, 8, 9, and otherwise, if it is not from 1 to 9, it's just out of range. And let's start this, run this. Okay, it's out of range. I have 5, works correctly. I have 1, works correctly. I have 100, it's out of range. I have 0, it's out of range. I have -3, it's out of range. I have 8, works correctly. I have 9, works correctly. I have 10, out of range. So this is how we can use sequences of if, else, if, and finally else. This is a very, very good example how we can check many conditions and print different things or do different actions according to this condition. This is the solution I had in mind before the start of this lesson, but it's very, very similar to the one I already demonstrated to you. Let's talk a little bit about variable scope. Variable scope are the ranges where the variables are available for use, and they are related to the time period where the variable holds some piece of the memory. Because some variables are needed for the entire program, they are called global variables. Some variables I need it for just temporary to make some calculations, and they are not needed later. In Java, variable scope defines the range of lines in which the variable can be used. And the variable scopes is very simply defined. It starts from the curly bracket opening and ends with its corresponding closing curly bracket. It's very simple. See this example. We have current day is Monday. If current day is Monday, we have salary, which is read from the standard input from the console. And here, the scope of this variable declared salary is this block. This block is the block where this variable lives. Its scope is only this block. It's not available here. If we try to access it, we'll have a compile time error. I'll show you this because it's important to see this in action. So if we declare salary here, we don't have salary here. If we declare so it's a compile time error. If we try to run this, we'll have an error. It says, I don't know what is, okay, we need a scanner, but it's not the problem here. I'll add it, the scanner, okay, but it still has this problem that salary is out of scope here. It can be found. If I declare this salary earlier, okay, like this, it will be accessible here. So this definition is here. It starts from this and ends here. So in this entire block of code, we have the variable salary. The scope of salary is this blue block, including here. So now we can use it. So if salary is 0, and if it is Monday, we'll read it. Now this program will work as expected, and we can assume that, for example, the salary is 4,000, for example. Okay, and it's printed. So this is the rule for the variable scope. Scope is the range of lines where a variable can be accessed. Variable scope starts from the opening bracket, curly bracket, and stops in the closing curly bracket. And that's all. It's very simple. Okay, let's go ahead with the next topic. It's called debugging, and I will show you how to use the debugger. I have already mentioned how to use the debugger. This is the way to trace the program and use breakpoints and evaluate the values, but let's show it in bigger details. So debugging in programming is the process of tracking the code execution in order to find some bugs or defects or mistakes. So debugging allows to find where our bugs are because it allows tracking our code. It uses thing called breakpoint. This is called breakpoint, this one, and it's a stopper, a place where the program should stop. We can add a breakpoint using the Control F8. In the IntelliJ IDEA, we can start the debugger with Shift F9, and we can go to the next one, but F8. If we don't remember these key combinations, you can just go here at the Run menu, and we have debug. Do you see? Step over, F8, step into. I'll show you how to use this. Okay, so I'll take these numbers words, okay, and I will put a breakpoint here, okay, and I say debug, or I can use this debug Shift F9, okay, and I'm here and I print, for example, 5, okay, but it's not this application. We debug something else. I'm sorry, this is main. So I should debug. In fact, I run for debugging this project, not this. So I need to debug this one. Okay. So now my program execution is stopped. I am at this point here at this breakpoint. I can press F8, which means please execute the next command. The next command reads something from the scanner, from the console. I'll print 7, for example. And now I'm here. What's num? Num is 7. Is it true that num is equals to 1? I can use this in the just to see evaluate expression. Is it true that num is 1? It says no, it's false. It's not true. Okay, so I can access the variables here, and I can see what are their values. Do you see this here? I have the scanner. The value of scanner is this one. It's a kind of object. I have these arcs, which are here. This one, this is a variable arcs. This is a variable called scanner, and this is its value. It's a complex object, and num is 7. I can press F8. Press F8 means go to the next command. It's like this. Step over. Step over. F7, F8, okay? Check whether it's num is 5, it's not. Else, check for 6, it's not. Check for 7, F8. It says, oh, it's true. Num is 7, so I go here. F8, it's printed and it goes just after this if-else statement at this line. If we had something here, it would be executed, but it's printed 7. So if we have a mistake, for example, bug, I run this program, okay, I run this program, and I print 7, and it says bug. And I don't know where to look, where this bug comes from. So I can run this in the debugger and trace it. F8, I will press, oh sorry, I closed the console, 7, and I execute this step by step. Ah, this is, it prints bug, but it should not be bug, it should be 7. So this is how I can find my problems, my mistakes in the program and fix them. So I fix the bug and I run it again, and it will, now it runs correctly. So it's very easy here, but if we have some kind of expressions, more computations, it may happen that we can find the problems using the debugger. So the debugger is very important and very intelligent tool that developers use to find the bugs. They usually put breakpoints at places where they believe their program might behave incorrectly, and they stop there. They trace the program one by one and find the problems. I'll show you this in many times when I solve some problems, and when I have some bugs, I will use the debugger and you will learn how to use it also. Okay, it's your time to solve some problems. Usually in our lessons we'll have some things which I will show you initially with some new material, like today's materials, comparison operators, and using the if-else sequences of checks. And you have to code, to practice all of this in order to learn it, because if you just watch the video, you will definitely learn nothing. You will just know that there is something called if-else, but you will not have the skills. You have the knowledge, but not the skills. To develop the skills, you need to code. So please now try to solve your exercises, which are in the homework section of the learning system, and try to write the code and solve all of them. And later, in a few minutes, I will be back and I will show you my solution. So go ahead, you have some time. Hello again, and I hope that you have some success with the problem solving session. And I will now give you my solution to the practical coding exercises from this lesson. So the first problem is called Guess the Password. It's about writing a program which is checking a password for a certain pre-given phrase, this one, secret exclamation, and it just takes a password guess. If it is this sequence of letters, it says welcome, otherwise it says wrong passwords. So this is an example. The input is secret exclamation and output is welcome. Or if we put the incorrect password, it says just wrong password. Okay, so I open the IntelliJ IDEA and it looks like okay, I'll create a new Java class which will be called password guess. Password guess. Okay, works correctly. And I have a class. I'll put the main method, and I'll have a scanner with control space equals to new scanner of system.in. Okay. Oh, the autocomplete in IntelliJ IDEA is very nice. So the next thing is to read the password. So it would be something like string pass word equals to scanner dot next line. Next line, I said. Okay, and now if the password equals to this thing here, secret, okay, then I will print welcome, and otherwise I'll print something like, oh, it's welcome, it's wrong password. Okay, let's test this. Run password guess.java. It takes some time. Okay, hello. Oh, it's not the password. Let's try this one, secret. It's wrong password. Oh, because I use equals. It's not working like this. Dot equals. I forgot something which I told you many times. The equals operator in Java doesn't work for text. Okay? Let's try again now after the fix. If I use this, it's welcome. If I use this password, it's incorrect. If I use S3CR3T exclamation, it's welcome. So I'm ready, and remember again, use dot equals in Java, because this is how it works. It's stupid, it's bad, it's unpleasant, but this is how it works. So you read the password and you check with password dot equals the other one, and equals operator doesn't work. Okay, if it is correct, welcome, otherwise print wrong password. Okay, let's go ahead with the next problem. The next problem is called boiling water. It's about writing a program to check for boiling water, and the program reads number, the water temperature in degrees in the Celsius scale, and it prints the water is boiling if the number is bigger than 100. It's considered that the water is boiling if when it reaches more than 100 degrees in Celsius, and this is at the sea level, at the sea elevation. If it is elevated higher in the mountain, this number could be less, for example 90 degrees, but this is just for curiosity in the physics. So the water is either boiling or it's not hot enough in all other cases. This is an example, 104.8
the water is boiling. If the degrees, the temperature of the water is 29, the water is not hot enough. Okay, I will take this password guess and to print Ctrl+C, Ctrl+V. It's called boiling water. The class is boiling water, and it will take a double temperature. I hate this word. Next double. Okay, and now if the temperature is higher than 100, it's boiling water. Otherwise, the water is not hot enough. It should be something like temperature. I hope I wrote this correctly. So I need to test this. 105.33 is boiling water, and 100 it's not hot enough. -5 it's not hot enough. Okay, the water is not hot enough. The water is not, yeah, looks like it's correct. So this is the temperature, degrees, we read it, and it's very similar to the previous problem, so we are ready. Okay, the next problem is called speed info. We enter a speed, which is a number. We check the speed, whether it is fast or slow. We consider that speed less than or equal to 30 kilometers per hour is slow, and bigger than 30 is fast. 30 slow, 60 fast. It's very similar to the previous problem. So if you want to solve this faster, I will take this boiling water, Ctrl+C copy, Ctrl+V paste, and I will say give a new name, speed info. So I have a cloning of the previous problem's solution of the previous class, which is called speed info. It reads speed, and if the speed is less than or equal to 30, it is considered slow, otherwise it's considered fast. Let's run this, click, double right click, run. I'm waiting for this to be compiled. So 35 kilometers is fast, 140 kilometers per hour it's fast, but 25 kilometers per hour is slow. That's all. It's very easy. This is how it can be implemented, but it's exactly the same logic. So we can go ahead with the next problem. The next problem is called area of figures. It's about writing a program to calculate the area of certain figure, which might be a kind of square, rectangle, or circle. The program should read at the first line the type of the figure, for example circle, reads the size of the figure. It might be one integer, for example the circle radius, or two integers, for example width and height, if it is a rectangle. So the figure might be square, rectangle, or circle. If it is square, the size is the radius. If it is rectangle, it needs to read the width and height, two integers. And if it is circle, it should read another. It's the radius. If it is square, it's the side. The side. Okay, let's draw this. This S is the side of the. If it is square, if it is rectangle, it has width and height, for example. And if it is circle, it has the radius, this size. Okay, but in fact we need to read the string, check the string with some ifs, with some string comparisons, and later either solve the problem about calculating the circle area or solve the problem about reading the size of square and calculating the square area, or reading rectangle width and height and calculate the area by multiplying them. So the area should be calculated
formatted to the second digital decimal after the dot after this, the floating point decimal separator. Okay, so let's create a new Java class which will be called area of figure. Okay, I click main. I'll need the scanner equals to new scanner control space of system.in. It's fast to write this using the autocomplete in IntelliJ IDEA. And now I need to read the type. String type equals to scanner dot next line. I can't type this. Next line. Okay, finally I survived to succeeded to write it. If type equals dot equals up circle, then I will read the circle. I'll do this later. I want to have the if-else constructions first. If else, if it is square, we do something else. Else, if it is rectangle, I'll do this, and else I will print invalid figure or unknown figure. Okay, so let's write the missing logic. If it is circle, we'll have table radius equals to table.parse it should be double.parse of scanner dot next line. I can't type next, I'm sorry. Okay, or we may use scanner dot next double, but this, if we combine next line with next double, things may get broken. If first we read this and second this will break. If we read first string, first whole line and then this will work. So we can do like this, but for to be more sure about it, it's better to use the other construction. But finally, the double result or area equals, I can declare the area here, double area. I'll declare it here. It's the radius multiplied by radius multiplied by math.p. You know this math.p. It is this constant. Okay. I'll close this. I open this window by control and the mouse pointer. And now I want to print this, print f, something like percent dot to f slash n and the area. Okay, this is how this works. Let's see whether this works. I'll start it and I'll try it. I have run. I have circle and the radius is 5. Works correctly. If it is square, it will be something different. I'll copy this because it will be easier. The side is the next double, and the radius is the side multiplied by the side, and that's all. And this is the area. Let me check whether if it is square of size 5, 25.00 works correctly. If it is rectangle, I'll have width, I'll have height, and the area is width multiplied by height. Let's run this. Rectangle of size 4.5 and 2. It's 11.0. Works correctly. And finally, it's a noun figure. That's all. Works completely correctly. So, if it is circle, we solve this problem. If it is square, we solve this problem. If it is rectangle, we solve this problem. And finally, we say a noun figure in all other cases. For example, if I have a trapezoid, it's a noun figure, so I cannot calculate its area. Okay, I believe we solved this problem, area of figures, correctly, and this is the solution I had in mind before starting writing the code. Is just read the type of the figure, check for square. If it is square, solve the square problem. If it is rectangle, solve the rectangle problem. If it is circle, solve the circle problem. And finally, you may print the area. Well, so in this solution, we have this here, okay? Something like finally, we print the area here, and we don't print it here and here, and we have double area is 0, and we do this. Do you catch the idea? We have only one printing and many cases here, but we don't have the else case if it is a noun figure. I will return back my solution, but the other one is also possible to have only to avoid duplicated this one, because this one is duplicated 3 times. So do you see? Okay. So this is the solution, and we are ready for the next problem. Our next problem is called ticket price. It's about writing a program to calculate the ticket price, and the program reads the ticket type. It is either student or regular, and the price should be printed as dollar and the price, like $60, $0. So the student price is 1.00 and the regular price is 1.60. There is a mistake here, because student price should cost less than the regular price. Okay, and if the price is invalid, it's just invalid ticket price, ticket type. So it's just a single if and printing. So it is very similar to our speed info, for example, or password guess, but I'll take this speed info and we'll say copy paste. This will be ticket price, and I'll read the string. Okay, or I can type just var ticket type, and it will be next line. Next line with small letters. Okay, if the ticket type equals normal, it will print the price which is toward 1.00. Otherwise, I'll take this. Else, if it is student price, it will be 1.60. Shift tab. Otherwise, it's unknown ticket type or invalid ticket type. Okay, invalid ticket type. So let's run this. So I have student price, it's 1.60. Okay, the normal is 1.60 and the ticket is 1.0. The student is 1.0, the normal is 1.60, and the special price is invalid ticket type. Looks correct. So let's see what solution I had in mind. It's very similar. If it is student, this price. If it is regular, this price. If it is otherwise, it's invalid ticket price. So I just have if else, if else, else. That's all. If else, if else. Okay, as a sequence of if else constructions, a series of if else construction. Very simple and okay. Let's go ahead with the next problem, which is called coffee shop. It's about writing a problem to calculate the price for a drink in a coffee shop. The drink might be either coffee or tea, which costs differently, and it might have sugar or not sugar. For example, I have coffee with sugar, or tea with sugar, or coffee without sugar, or tea without sugar. We have just 4 cases. And the price should be printed in the format final price column and the final price with the dollar prefix. So the coffee costs $1, tea costs 60 cents, and sugar costs $0.40. So coffee with sugar should cost 1.40, just like this, and tea without sugar should cost 0.60. That's all. It's very similar to the previous one, but not exactly. So I'll take this ticket price, Control C, Control V, and we'll call this class coffee shop. Okay. Oh, it's a mistake. Control RR. I want to rename this. Shift F6 maybe. Yes, coffee shop. This and this were both renamed correctly. So the first thing I read is the drink type. Okay, drink. I take the previous lessons, the previous problem solution, because it's easier to start with. So if I have coffee, okay, but I don't know whether I will have sugar or not. So I should have something like price is 1.60. So I start with something like double price is initially 0. I start from 0. If it is coffee, I assign 1.60. Otherwise, if the drink is tea, I will set price to 1.00. And this is the first type. Okay, to start from price 0, to read the drink, and to assign the correct price depending on the drink. Okay, but after that I need to read it will be something very similar. I will need to read the extra, and if the extra is sugar, the price will increase by 0.40. Is this correct? Yes. And otherwise it will not increase at all. And finally I'll need to print F the it's something like dollar followed by percent dot to F. This is the format string I use, and the price. No, it should be final price. It should be final price, and this one here it's incorrect, and this it should be, oh, let's fix it. It should be final price I need to paste this. It should be something like this. Okay, 0.60. 0.60 is just a bucket the problem description, right? So okay, this is what we have here, and it maybe needed to be moved to the left, but okay, that's enough. So the idea here is that we need to print this. This is what the problem statement says. So we print this and we give a second parameters, the price. Okay, let's run this. What this says, I don't know. It's just some kind of coloring. But generally, I will try to order coffee with sugar as a start. Hey, give me the program. Coffee. Oh, it's invalid ticket type. No, I want to run coffee shop, not ticket type. It was the previous class, the previous solution. So I need coffee with sugar. $2, 1.60. No, it is 1.00 the coffee, and the tea is 0.60. Okay, I'll try again. Coffee with sugar. It should be 1.40. Okay. Oh, the sugar is 40. Okay, coffee with sugar, 1.40. Final price 1.40. Okay, I'll start it again. Coffee without sugar, $1. Okay, and tea with sugar, it's $1. Okay, and tea without sugar should be 0.60. Tea without sugar, 0.60. Oh, looks correct. We don't have else here. We don't check for invalid, but it's not required by design. We may have here else, something like invalid drink, and I should do this return, which stops the program execution. It returns out from this main method. Let me show you. So if I want, for example, iced tea, it says invalid drink. Okay, and here else if extra dot equals of no, I do nothing because it's free. But otherwise, or if the extra is not no, I should say invalid extra and return. So this is my final solution, which also handles invalid drink situation, and it also handles with extra, which is different than sugar and no, and will give a problem. So if I order whiskey, it's invalid drink. But if I order a tea with ice, it's invalid extra. But if I order a tea with sugar, that's correct. If I order a coffee with nothing, it's correct. Looks like this works correctly. So we can see what solution I have prepared. We read the order, we read the extra, and if the order is coffee, we set the price. If it is 3, we set the price. If it is something else, we print error message and return. If the extra is sugar, we increase the price. We add additional value 0.40 to the price, and finally we print. This code doesn't handle the error situations, but I have shown you already how to handle them. Okay, so what's next? The next problem is called valid triangle. It's about checking whether three sides can form a triangle. So let's start from here. In math, if we have triangle and it has three sides which build it, they have a length of A, a length of B, and a length of C. But if it happens that C is bigger than A plus B, okay, if A plus B together are smaller than C or equal, this is not triangle, because if it is too small, if A and B are too small, if these sides are too small, they cannot create a triangle. So the idea is check whether three integers can form a triangle. So we should check if each side is lesser than the sum of the other two. If this happens for all the sides, the triangle is okay. But if certain side is bigger than the sum of the other two, it's invalid triangle. So this is an example of valid triangle 3, 4, 5, and invalid would be something like if we have here 25, for example, because these are 7, but this is 25. So we have 3, 4, and 25. It's obvious that we cannot create a valid triangle using these three sides. So let's solve this problem. It's a little bit more complex than the previous one. It will be called valid triangle. Okay, so in the valid triangle we'll have the main method. We'll say scanner, control space scanner, new scanner of system.in. Okay, and we read the site. So double site. Okay, A equals to scanner.next. Oh, I cannot type next. Okay, I'll copy this 3 times. Sorry, Control C V V 3 times. A, B, and C. So what will happen if A plus B is less than or equal to C? Is valid or invalid? We have two sides which together are smaller than the last one. So this is invalid. Invalid triangle. Also, if we have A plus C less than B, it's also invalid. But I should have else, because otherwise I may encounter a double invalid triangle. I need to print just one output message. Otherwise, if A plus B plus C is less than A, it's also invalid. And finally, if this happens, if the first, the second, and the third side are correct, the triangle is correct. Something like this. I use double. Should be done with integers, but it will work as well, 3 integers. Okay, let's see whether this works or not. So I have 3, 3, 4, 5. It's valid. Okay, if I have 3, 4, 25, it's invalid. If I have 104 and 5, 1000, it's invalid. Looks correct. I can do something else. If this or this or this, I have invalid. But we didn't have learned already this. This is called OR, logical OR. logical OR. We'll learn about this in the next lesson just to demonstrate that this works, and this makes your program shorter and more readable. 3, 4, 5 works correctly, and 100, 3, 4, it's invalid. Okay, so I'll return back this solution because this is what you should do with the skills you have today. Okay, so this is another solution I had in mind previously. I have a Boolean variable which initially starts from true. We consider a triangle is valid until proven the opposite. So if I find that A plus B is less than C, so A plus B is, no, it's not less. A plus B, okay, yes, if A plus B is less than C, so if C is too long, this is A, small B, and very long C, we say the triangle is invalid. If A plus C, if B is too long, sorry, we set is valid triangle to false. And if A is too long, we set invalid to false. And finally, we print the result, is valid or invalid. So we have if this, print valid, otherwise print invalid. It's very similar, but I can do this. So Boolean valid is true. If this happens, valid will be false. And if this happens, valid will be false. And if this happens, valid will be false. And finally, if valid, I'll print this. Otherwise, I'll print valid. Otherwise, I'll print invalid. This is another solution. See? It's just, I consider valid. If I find invalid side, either C, B, or A too long, I change this variable and it holds whether it's valid or not. So if I have, just a moment, 3, 4, 5, it's valid triangle. But if it is 3, 45, this is too long, so it's invalid. Okay, this is the solution, and this was the last problem. So I'm happy that we have successfully passed this lesson, which was about the conditional statements. And I already explained that the logical expressions are built using a comparison operator and some operands, some values, so we can compare, for example, if H is less than 100, or if, for example, if the temperature of the water is less than 100, it's not boiling, things like that. So if we create this comparison, we can use if or if else statements. If something, do some comments, otherwise else, do some other comments. You have seen how to use this, and we can use series of if else checks to implement more complex change of comparison, change of conditions, chains of conditions. Okay, and we explained what is a block, this thing which starts from the opening curly bracket and continues and holds some comments, 0, 1 or more, with semicolon after that, and stops with the closing. It's all starts with opening bracket, curly bracket, and ends with closing curly brackets. So variables defined between two curly brackets have the scope and are valid only here. So in this here, A, B, and C are valid from this place until this place. If I put a bracket here and a bracket here, A, B, and C here will be unavailable. So this is the variable scope and blocks. And I have shown you how to use the debugger and breakpoints. I will repeat this again. I put a breakpoint by the mouse click, I say debug, and here I say A F8. Okay, I read. Sorry. Okay, I will read ABC and we'll stop here with the debugger. It will be easier. Okay, I read 3, 4, 5, and here I can trace the valid. Valid is true. Currently F8, this is false, this is false, this is false, so valid is true, so I print this. So I can train the code execution step by step, one by one, and if it behaves incorrectly, I find which one is the problem and I fix it. So this is called debugging, and it's implemented by using the debugger and the breakpoints. So this was the entire content I wanted to transfer to you as knowledge and skills, and I hope you have solved, or you will solve your assignments. You write the code in order to get not just knowledge, because if you watch the video you will get knowledge, but also the skills, the practical skills of coding. So focus on your homeworks if you didn't do this, and I'll see you for the next lesson where we'll explain more complex things about conditional statements. Now it's time to start writing more complex program logic. I will show you how to use complex conditions in your if statements, how to use the logical OR, logical AND, and logical NOT operators, as well as brackets, to design more complex checks. Additionally, I will demonstrate you through examples how to write nested if-else statements and longer sequences of if-else constructions. Together, we shall solve several practical problems. And as usually, you will have a homework assignment to solve a few hands-on exercises that combine complex and nested conditions for processing some input data and calculating and printing certain results. Let's do it! So let's take this example. It's a real-world example called marketplace. So in a marketplace we have different prices for certain products based on the day of week. So in the weekend, banana are sold by 2.50, and in the weekend they are more expensive, 2.70. Apples are 1.30 in the weekday, and in the weekend they are 1.60. And it's similar for other products, and depending on the weekday and weekend. So we want to calculate the price for a certain product and date, and this might be expressed with if-else statements. But how to do this? It would be something like this. Read the input. What is the product and what is the day of week. So if the product is banana, we have two cases. If it is weekday, the price should be 2.50. Otherwise, the price will be 2.70. If the product is apple, again we have two cases. If it is a weekday, the price is 1.30. Otherwise, the price is 1.60. And again, if the product is kiwi, we have two cases. If it is weekday, the price is 2.20. Otherwise, the point is 3.00. So this is a pseudocode which explains that sometimes we need a nested if statements. So this is an if statement, but this is another if statement which happens if the first is true. It's called nested or inner if statement. This if statement happens only if the first is true. So this is how we can express more complex programming logic. Let's see how this happens in programming with Java. So with the nested conditions, we may have if-else inside another if-else. How to do this? An if-else statement can be nested within another if-else statement, like it's shown below. We have if expression and we have a block. Or we may have just a single statement later. In the block we have if some nested expression, do something, otherwise do something else. So if this is true and in the same time this is also true, this code will be executed. If this is true but this is not true, this code will be executed. So we have more flexibility if we nest if-else statements inside other if-else statements. So only if the first condition is true, the nested check will be executed, it will be evaluated, and if it is true, some code will be executed, otherwise this other code will be executed. So the final code is executed when the nested expression is false and the first outer expression is true. So we can nest this in such a way at several levels. So we can have if, in it we can have another if-else, inside it we can have another if-else, but it's considered that up to 3 nested levels are okay. Otherwise the code becomes more unreadable and complex to be understood. So please avoid deep nesting. How to avoid deep nesting? Usually we use methods. We all learn how to use methods later, but this is the way we can avoid it. Just extract a piece of code in another method and give a meaningful name. I'll show you this later in some of the next lessons. So let's solve one real world problem, our marketplace. We want to read the product and day from the console, and we want to print the price formatted to the second digits after the decimal point based on this price table. So banana in the weekday costs 2.50. Banana in the weekend costs 2.17. So we need to check the product and after that check the weekday, and with nested statements we can calculate the price. So if the input is the first one holds banana, the second holds weekend, the output should be 2.17. If the product is kiwi and the week entity is weekday, this is the price, 2.2. So this is our problem, and I'll solve it. But first we have conditional statements Java. This is the previous lesson. So I'll create a new project which will hold the exercises from my current lesson, which will be called Conditional Statements Advanced. Conditional statements with A statements advanced. Now it's correct. The base package should be empty. This will simplify our job, and I will open this in the current window. So the project, I have the same thing in C#. So I need to change the name. Sorry, I just opened a folder which already had some existing projects. So I'll create a new project with different name, which will be called Conditional Statements Advanced Java. Okay, I believe this is correct name, which is unique. And okay, this is the name, and these are the files inside the files. Okay, in src I have main, and I'll create a new class. So I created a project which will hold all my examples and homeworks for this topic, for this lesson, Conditional Statements Advanced with Java. And the first problem is called Marketplace. Marketplace with capital, because this is a class name and it should be with capital, and each word will be capital. For example, if it is coffee shop, it should be coffee shop. Each word with capital letter. This is the standard naming convention in Java. I create the main method, and I want to read the product and the day of week. So I'll declare a scanner, control space scanner equals to new scanner of system.in. Okay, I have the scanner, so I can read the product. So var product equals to scanner dot
next line, and again I can read the day of week. Okay, so I'm ready with the input. I can check the product. If the product is banana, but this is incorrect in Java with equal, so I should put dot equals in brackets banana. I'll do something. Otherwise, I can check the product. I'll take this Control C, Control V, and this I will delete it. If the product, Shift Tab here, if the product is apple, I'll do something else. Otherwise, it's better to do like this. I have one bracket, which is not needed. If it is kiwi, I'll do something else. Otherwise, I will print invalid or unknown product. The program does not know this product. So if it is banana, I can have another check. If day of week, day without S, day of week is weekday, I'll print the price, which will be 2.70. I'll print it as a string, because otherwise, if I print it just as a number, I will need to format it with two letters, with 2 digits after decimal point. I want to make my life easier, so I'll do something like this. It's 2.7, 2.50 in the weekday, banana, in the weekdays 2.50, otherwise in the weekend is 2.70. Okay, so the similar logic matches the apple. Apples in the weekday cost how much? 1.30, and otherwise 1.60 in the weekend. Okay, and here I'll need, for the kiwi I have 2.2, 2.20 and 3.00, 3.00. Let's try. So I want to buy apple in the weekend. Apple in the weekend, 1.60. Okay, what's next? I can try kiwi in the weekday. Okay, it's 2.2. I can try banana in the weekend. It's 2.70. So this is how it works. I have if, which holds other if, which holds other if. So I can just I can split this, but it's very ugly. No, this will not work well. But generally, I have if, it holds if. I have else if, it holds another if. I have else if, it holds another if. Here, I may have like this, a block, and I may have other if something, print this, otherwise print this. So this is how I can have deeper nesting. Okay. Okay, so
this is how marketplace could be solved, and this is what the solution I had in mind before the start of my lesson. If the day of week is weekday, for banana is 2.50, otherwise 2.70. If the product is Apple, for weekday I have one price, otherwise if it's not weekday I have another price. I do the same for kiwi, etc, etc, etc. So the biggest number of 3, this is our next problem. It's about writing a program that reads 3 numbers from the console and prints the biggest of them. Wow, it's a little bit more complex. So if I have 1, 2, 3, 3 is biggest. If I have -1, -5, -9, -1 is the biggest, obviously. If I have 1, 5, 3, 5 is biggest. If I have 0.5, 1.5, -3, 1.5 is the biggest. So how to solve this problem? Okay, I'll create a new Java class which will be called biggest number of 3 numbers. This name is good enough because it says what inside. Biggest of some 3 numbers. Okay, here I'll take this line of code because I don't want to write it again. I'll write main, we'll import Java to scanner, and I'll say something like double num1 equals to scanner dot next double, and I'll have num1, num2, num3, and I'll check if num1 is bigger than num2. This means that num2 is not the biggest, right? So this says nothing. I'll need another if. If in the same time num2 is bigger than num3, what this says? This says that the num1 is the biggest. Do you agree? Num1, for example, 10, is bigger than num2, for example, 5. But num2 is bigger than num3, for example, 2. So which is the biggest? Num1. Okay? But this is just one of the case. Otherwise, what we have here? Otherwise, num3 here, num3 is bigger or equal than num2. And in the same time, num1 is bigger or equal than num2. We can say nothing. We need another if here because it's not clear which one is bigger. It might be either num3 or either num1. So this is not good. Okay, what about this logic? If num1 is bigger than num2 and num1 is bigger than num3, this num1 is bigger by both num2 or 3. So it's the biggest. For example, this is 10, this is 7, this is 5. And otherwise, what will happen? Because num1 is bigger than num2, and in the same time, num1, num3 is bigger or equal to num1, which is bigger than num2. What happens here? Num3 is the biggest. Do you agree? Let's give an example. Num1, for example, 10, is bigger than num2, for example, 5. And num1 is not bigger than num3. For example, this is
12. Because this is 10. So which is the biggest? The num3. Because num3 is bigger or equal than num1, because it's else. The opposite of this is this. This is the opposite here. So if this happens, and in the same time this happens, it's obvious that the num3 is the biggest. Do you agree? I believe it's correct. But here, else, what we have here, if we go at the else, this means that this is not true. This means that num1, num2 is bigger or equal than num1. So if in the same time num2 is bigger or than num3, what happens? Num2 is, for example, 10, is bigger or equal than num1, for example, 5. And in the same time, this 10 is bigger than num3, for example, 3. Which is the biggest? Num2. So here, I will print num2. Otherwise, what happens? Num3 is bigger or equal to num2, and in the same time, we have this. Both are correct. So this means this. Okay? It's the same. So which one is the biggest? Num3. Okay? Do you agree? I believe so. And this should work correctly. Let me check whether it's correct or not. Oh, go away. I will try 10, 20, 30. 30 is the biggest. I agree. 30, 20, 10. 30 is the biggest. And 20, 10. 20, 30, 10. 30 is the biggest. So I had the first, the second, and the third. So if I have 1, 2, 3, the last. If I have 1, 3, 2, it's the middle. And if I have 3, 2, 1, it's the first. I covered all the cases, in fact. And maybe I should type 5, 5, 5, but it's 5. I should try negatives, minus 1.5, 0.5, minus 15. 0.5 is the biggest. Looks like it works correctly. So this was a little bit more complex logic. Yes, it is more complex logic because we still didn't have learned about the AND operator. Because if this is true, this would be more easier to read. Do you agree? If num1 is bigger or equal to num2, which is bigger or equal to num3, then it is num1. How to write this? It should be like this. And this is the first case. My second case might be this. Num2 is bigger than num1 and num2 is bigger than num3. Oh, this is the case. Num1 is bigger by both num2 or 3. So it's the biggest. Num2 is bigger by both num1 and num3. So it's num2. And the third case is that num3 is bigger by both of them. This is the second solution, and this will work also well. But we didn't have already learn how to use this AND operator. I'll talk about it a little bit later. So let's go back with our nested if statements based solution. This is a solution based on nested statements. This one, and it's completely correct. Okay, so the solution I had in mind before the start of this lesson is check whether the first is biggest by the second. If the first is in the same time biggest by the third, it's true that first is bigger by both second and third. Otherwise, the third is bigger than first, and which is bigger than the second, so the third is the biggest. Otherwise, we have that the second is bigger than the first, because it's the opposite of this. And in the same time, I have second bigger than the third, so second is bigger than both first or third, or equal, but this doesn't matter. And otherwise, the third is bigger than the second, because this is not true. And in the same time, the second is bigger than the first, because this is not true. So third is the biggest. This is exactly the solution I had, but I didn't name my variables num1, num2, num3, but first, second, third. It's the same solution. Okay, let's go ahead and try to solve this yourself, because it's a little bit more complex logic than the things we already mentioned in our previous lessons. So in programming, we often have some non-trivial things that we should just be smart and think of and invent them. So this is called algorithmic thinking, to come up with a correct idea to solve certain problem. Okay, let's go ahead with the so-called logical operators. This, not, and, or, operators which allow us to build more complex conditional statements, more complex conditional statement logic, to check more complex conditions. Sometimes we often use logical conditions. Things like check whether the minutes are less than 60, or check if the price is bigger than 1.50. This is called a logical check or logical condition. But this is a simple logical condition. Just value, operator, another value. Value, comparison operator, another value. But what will happen if you want to check several conditions in the same time? Check whether the minutes are less than 60, and in the same time, the price is bigger than 150. Or if the first is bigger by the second, and in the same time, the first is bigger than the third. This is an example of more complex logical operators. So the logical operators in Java combine several conditions. They can be combined with the AND logic, logical AND, or the double ampersand operator. It says the first condition and the second condition. I'll show you how this works. Logical OR, either the first or the same or both. This is called OR. Let me give you a real world example for AND. If I'm a male, and in the same time, if my age is over 21, I can enter in the certain nightclub alone, for example, if both conditions are in the same time true. Or if I'm over 21 years old, or I come with old person, I can enter in a certain club. To enter in certain club, I should either be old, of age more than 21 years, or I should come together with someone which is old. This is OR, logical OR. And not means If I'm not under 21 years, I can drink beer. For example, logical negation. Also, we may have brackets. Brackets change the order of execution. And this is just when we don't know the exact priority. I'll show you how to use the brackets. But they're just like in math. In math, the multiplication has higher order of execution than plus and minus. So we can use brackets to change the order. It's the same applies for Boolean expressions and logical operators. So the logical AND this operator ampersand ampersand double ampersand, it's true when both conditions are true in the same time. So if I'm old enough and if I signed an agreement, I can purchase, for example, a car. I should have 21 years and I should sign some documents. I can purchase a car. Both conditions should be true in the same time. The OR logic is like this. If the first condition is false but the second is true, the OR means one of them, so it will be true. If the first is true and the second is false, the OR condition will be true. So if I'm old or come together with someone who is old, I'm allowed to enter in the club. It is in Java the vertical to vertical lines. This is called OR, logical OR. But the OR works if both conditions are true. If I'm old and I come together with a friend who is also old, I will also be allowed to enter in the club. Okay? And negation means the opposite of something. So if I'm not under 21, if I'm 21, if my age is less than 21, I'm not old, I'm young, okay? But if I'm not under 21, I'm considered old. This is a negation. This is the exclamation mark operator in Java. I'll show you how this works in practice with some code. This is an example of Boolean expression which returns true if all the operands are true. Assume this this problem here. Sorry. I have a point xy, and this point is inside this rectangle if 4 conditions are true in the same time. It is on the right from this x1. It is on the left from this x2. It is on the down from this y1, and it is on the up of this. So if it is on the right from this side, and on the down from this side, and on the left from this side, and on the up from this side, if these 4 conditions are true in the same time, this point is inside this rectangle. Do you agree? Yes, it's true. So if the position x of this point is on the right from x1, the right from here, and in the same time if x is less than x2, which means this is x2, 12, this is 12, left from here, less than x2, and it is bigger than y1, which means this, and it is less than y2, which means this. If all of them are in the same time, this means that it's inside. So this is a very good example how to use AND, logical AND. Another example is to write a program which adds bonus points to given number. So we have achieved some result, and if the result is from 0 to 3, we add 5 bonus points. If the result is from 4 to 6, we add 15 additional bonus points. If the points are between 7 and 9, we add 20 additional
bonus points. So this is how this can be implemented. If we have 4 points, we add more 15 and our result is 19. How this can be implemented? Bonus points. We read the bonus points. If the points are from 0 to 3, we add 5. Otherwise, if points are from 4 to 6, which means the points are bigger than or equals to 4, and in the same times bonus points are less than or equal to 6, this means that we have range 4 to 6. This is how we express this in Java. Okay, I will create a class called bonus points, and in the main I'll take this scanner from here, Control Tab, switch to the next editor, to the next file, which is already open. I will read the points. Double points equals to scanner dot next double. And now if the points are between 0 and 3, between 0, bigger than 0, and points are less than or equal to 3, then I add 5 points. Otherwise, I have something very similar, so I copy this. If they are from 4 to 6, I will add 15 bonus points, right? If they are from 7 to 9, I will add 20 more points. And finally, I'll print the final result. What will happen if I have 4.3 points? 4.3 falls here. So plus 15, I will have 19.3. What will happen if I have 0.7? With more 5, I have 5.7. What if I have 9 points? More 20, I will have 29. What if I have 0 points? I will have 5. What will happen if I have 100 points? I will stay with the same because there is no bonus for this range. This is how the logical AND works. It checks the first condition and second condition and third condition, etc, etc, etc. So this is the solution of the problem I already demonstrated to you. So let's go ahead to discuss the logical OR operator. The logical OR operator is some operator whether the result of the expression is true if one of the operands is true, or both of the operands, or left operand or right operand is true. If one of the members of this OR expression is true, the entire expression result is true. Otherwise, it's false. So if S is tea or S is water, this will be true. I don't need this. If S is tea or S is water. So let's solve this problem. Check for food or drink. Whether something is food or drink. We read a single line and print drink, food, or unknown. We consider that the foods are curry, noodles, sushi, and spaghetti. That's all, only 4 types of food. And drinks are tea, coffee, and water. Okay? So everything else is unknown. How to solve this? This is called food or drink. Okay? I'll copy this, Control C, Control V. Food or drink. Okay, and I'll start from this template. I'll have a string with capital S equals to scanner dot next one. S is our input or item, for example. It might be item. If the item is curry, okay, or the item is noodles, I'll copy this, or the item is sushi. I think I don't need this, but what will happen? Oh, it's too long, the line is too long, so it's better to split it, maybe like this. Maybe like this, or the item IntelliJ IDEA wants this to be formatted in certain manner. Yeah, sushi, and finally I should check spaghetti. For spaghetti, if one of this or this or this or this happens, I'll print food, okay? I'll print this is food. Otherwise, I'll check for this. I'll check for water or tea or coffee, and if one of them happens, I'll need a bracket here closing, I'll say that this is drink. Otherwise, I'll say that this is a noun. Let's check whether this works. So in these 4 cases, I'll print food. In these 3 cases, I'll print drink. In all other cases, I'll print a noun. Let me check whether this works. I have tea, it's drink. Okay, I have water, it's drink. Okay, I have noodles, it's food. I have sushi, it's food. I have a banana, it's a noun, because the program doesn't know this one. So this is the solution, and this is how it works here. It's very similar without the blocks with opening and closing curly brackets, but it's essentially the same solution, just a little bit more less code. Okay, so let's demonstrate the logical not. The logical negation or not returns true when the operand is false, and false when the operand is true. So it inverts the value. Here is an example. We want to check for a valid number. By definition, a number is valid if it is in the range from 100 to 200, or in the special case where the value is 0. So valid numbers are 0, 100, 101, 102, etc. until 200. So we have a little bit more complex expression. So is valid, Boolean is valid, is this num is bigger than 100, and in the same time num is bigger than 200, this thing, or the num is 0. See, we may have here brackets also, but exclamation is valid means invalid. So if the number is not valid, it's invalid, right? So if it's false that the number is valid, this means that the number is invalid. It's the opposite of valid. So this is how this works. I'll say implement this also. Valid number check. For example, it would be something like main. I'll have this, the scanner. I'll take this because I don't want to write it again. Control V with the import. So I'll have a number var num equals to scanner dot next table. Okay, and now boolean valid equals to the following. Num is, let me see, the range from 100 to 200. Num is bigger than or equal to 100, and in the same time num is less than or equal to 200. This means that it is in this range. Or this happens. Num is 0. If one of these cases happens, the value is valid. If the value is not valid, print sorry, invalid value. Okay, I'll run this to show you. 5, it's invalid value. 100, it's valid. 150, it's valid. 200, it's valid. 0 is valid. 201, invalid. 50, invalid. So do you understand the logic? We can have this. So I can use this. I can have if brackets and this. What I wrote here is please check whether the number is between 100 and 200 or it's 0, and use the opposite of this. The opposite of this. And if this happens, say that the value is invalid. For example, 50. It's invalid. But it's better to split this complex condition into two more simple. This is highly more readable. It's much more understandable code. So prefer this code. It's called self-documenting, self-explaining code, because you say it's valid when this or this happens. If not valid, print this. The other complex condition in the if was hard to understand. Okay, let's go ahead with the next section for our lesson. It's called switch case. Switch case is a special operator similar to if-else, which allows checking for multiple values for the same input. So we check something, for example, the age of certain person, and if the age is 5 years, we print something. If the age is 20 years, we print something else. If the age is 10 years, we print something else. This is a way to check the same input for multiple values. This is how this works. It's used for choosing among a list of possibilities. Alternatively to if-else, we have switch, we write switch, and in brackets, we use the selector, which is an expression. For example, age. Switch of age. Okay, I cannot type this. Switch of age. And if the age is, for example, here 20, do something. Break. Otherwise, check. We may have many cases, many such cases. Default, do something. I will demonstrate this. So this is main. I have string day is is 5, for example. Int switch of day. And if the day is 1, in case of 1, I will print, in case of 1, I will print Monday, and I will break. It's not like this. You don't have this. It starts with, you always have break and you always have multiple lines. Just the syntax is a little bit strange. Case 2, the second day is Thursday, break, etc. And default, by default, I'll say unknown day. I will need finish the other days. Okay, so what's the idea here? If the day is 2, it's Monday, it's Tuesday. Okay, if the day is 1, it is Monday. If I skip this break here, this doesn't work correctly. Do you see? Because in case of 1, this will happen. But without break, this will continue. So in case of 1, this will go here. So you need to put break after these cases, except the default. Otherwise, it will not work correctly. It's similar to if day is 1, 10, print Monday, Monday, else if day is 2, then print Thursday, else print unknown day. So this and this do the same. But here it's more clear that we check the different possibilities for this day. Here we may have more complex and different expressions. So when to use switch? When we have the same expression and we choose for multiple values. Or it's a matter of personal preference. Some people use only if else and never use switch, but switch is sometimes more powerful and more convenient. So this is an example. We print yes or no. We print something. If the value is y, we print yes. If the value is n, we print no. Otherwise, we print invalid response. This is the example. Print yes, no. Yes, no. Main control space. And I'll need this scanner here. Control C. So I run this code. I run choice. I press Y, it's yes. I press N, it's no. But if I press Y with small, it doesn't work. It's invalid response. Okay? But what I can do here is to have multiple labels. In case of yes or yes, and in case of no small or no, print no. So this will work slightly better. Okay? Yes, it's yes. Y big, it's yes. No, it's no. And N is no. But if I print yes, it's invalid. So I can say that the choice is equals to choice dot to lowercase, and I will need just these two cases, because if I switch the big letters into smaller here by this one, of course, to lowercase. Okay, so if I have y, it's yes. If I have y, it's yes. But still, if it is yes, it doesn't work. So I can have that choice is choice dot substring of 0, 1, which means take the from the letter at position 0, 1 letter. Let me check whether this works correctly. Yes, works. Y works. Y works. No, it's no. Now this works better. You can play a lot with this. So this is the scenario to use switch case. We may have switch and many cases, and we may have default, which is something quite defined else. We may have multiple labels in the switch case, and I already demonstrated this, because we may have the same action for several values. This is an example: switch selector, case first value, second value, third value, some statements and break. Default, some statements and break. This is an example. Animal. In case of animal is dog or cat or something, it's mammal. Okay? Otherwise, it's a noun. So, in case it's, for example, eagle and pigeon, it's bird. I may have this. For example, species, biological species, name. So scanner equals new scanner of system.in. In this animal, if it is dog, cat, or for example frog, it's mammal. The frog, I'm not sure. For example, horse. The horse is mammal. And in the same time, I may have eagle, pigeon, and some, okay, just these two. It's bird. Otherwise, it's a noun. Switch of animal. Okay. I can rename this animals. Okay. So pigeon, it's bird. Do you know what is pigeon? It's very easy to find this. Just this one. This bird is called pigeon. This is eagle. Do you know it? The eagle. You can check the others. So this is the concept. Let me run it again and try, for example, cat. What's slow? What's slow? It's incredibly slow. But once it runs better. Once it's compiled. So if I use, for example, I don't know, some animal, frog, it's a noun. Okay. So this is the concept of multiple labels inside the switch case. It's really useful. And this was all of the new content I have had in mind for today. So it's your time to solve some problems based on the new skills we learned today. Because learning programming is only possible by coding. just writing code, solving problems. So it's your time to practice the coding exercises. Please do your best to solve these exercises, which are in the warning system in the homework section. And I will be back in a few minutes to help you and to show you my solutions. So go ahead, I'll be back. Hello again. Now I will help you to solve the problems you had to practice for your practical coding exercises. And I will start from the first problem, which is called fruit or vegetable. It's about writing a program to check for fruit or vegetable. It reads a single line of text. It might be either fruit or vegetable. So we consider that fruits are banana, apple, kiwi, cherry, lemon, and grapes, and vegetables are cucumber, pepper, and carrot, and everything else is a noun. So it just needs to read some input to check whether it is among these fruits or vegetables, and print either fruit or vegetable or a noun. This is an example. If we enter lemon, it should produce fruit. If we enter carrot, we should produce vegetable. If we enter, for example, coffee, it should print a noun. Okay, so let's do this. Fruit or vegetable. I will open the IntelliJ IDEA where I have a project about the conditional statements advanced lesson, and in the source folder I'll create a new class, new Java class, which is called fruit or vegetable. Okay, inside this class I'll have main. I will open some of the previous classes just to copy this line of code, which imports the scanner class. And now I'm ready to read my input. The input will be something like a string item is equals to scanner dot next line. It's an item. So if the item is dot equals, I think we cannot use switch because switch doesn't work for strings. But let's see, if items equal banana per banana, what was the banana, apple, kiwi, cherry, lemon, grapes? Oh, it's a product. Product is a better name. Is the product is banana, or the product is apple, then kiwi, then cherry, lemon, copy paste doesn't work well always. Kiwi, cherry, lemon, grapes, cherry, lemon, and finally I should check for grapes. If this happens, I will print that this is fruit. Otherwise, I'll have some other checks like, wow, Control V. So I copied this in order to write it faster. It's cucumber, pepper, and carrot. In this case, I print vegetable. Finally, I print noun. This is the entire program, the entire code. I think it's correct, but let's see. I'll start it, run fruit or vegetable. it's compiling. It still needs some time. So banana is fruit. Okay, thank you. So lemon is fruit. I agree, but what about cucumber? It's vegetable, but what about water? Water is a noun. Okay. Pepper, maybe this should be with double P. Yes, it is with double P. So we are done with this program, and let's see the solution I had in mind before the lesson. It's with switch. Switch like this, and I should check whether this works. I'm not sure that this works because I'm not sure that switch works for strings. We can check in Google. Java switch for string. Okay, switch string in switch in Java. Oh, this works from Java 7. So it looks that it should work, yes. As from Java 7, they have implemented this one. So I can do something like switch of product if this cucumber, pepper, and carrot is a vegetable. Sorry, Control C, Control V. If it is banana, kiwi, lemon, cherry, grapes, banana, kiwi, lemon, cherry, grapes, banana, apple. I have also apple. Then this is fruit. Otherwise, default, it is, in the default case, it is noun. I don't need break here. It shall work, but I don't need it because here the statement ends the case. Now I run, for example, this program and I enter apple. My first solution says fruit and my second solution says also fruit. If I enter T, both solutions say a noun. So this is the switch case. It looks better, to be honest, than this one. Okay, so this is the solution I had in mind before the start of this lesson, and I have demonstrated you how to use it. Okay, let's go with the next problem, which is called day of week. It's about writing a program to display the day of week as words. So if we are given 2, it should be Tuesday. If we are given 3, it should be Wednesday. So it should read an integer n, which is the day of week in the range from 1 to 7, and prints the name of the days as words in English. It's assumed that the first day in the week is Monday, which is not everywhere in the world, but we assume this like it is in Europe. So prints error if the number is not in the given range. This is an example. 1 means Monday, 9 means error, and 7 means Sunday. Okay, so let's solve this problem. It's called day of week. New Java class, day of week. Okay, Control Tab goes here, and I will copy some of the code from the previous problem, and it would be something like please read the next int in the variable called day, and I will switch of day, and in case of 1 I will print Monday, and I'll take a break. I'll exit from the switch. I should have 1, 2, Tuesday, 3, Wednesday. Looks correct. 4 is Thursday, 5 is Friday, oh, my favorite day, 6 is Saturday, and 7 is Sunday. And the default is, it should be on the left, is error. Let's run this. So this is the entire code, you can see it, the entire program. We have written 33 lines of code. Wow! So today we wrote a few hundred lines of code if we combine all the code we wrote together. So if you want to become a developer, you need to have few 100,000 lines of code. Looks good. This means 1,000 days per few hundred lines of codes, or more intensively. But let's go here. 3 is Wednesday, 0 is error, and 7 is Sunday, and 1 is Monday. Looks correct, so we can go ahead with the next problem. This is the solution I had in mind before the start. It's exactly what I already implemented here. So let's go ahead with the next problem. The next problem is called vowel or consonant. It's about writing a program to check a letter for vowel or consonant. So we read a letter from the English alphabet as input, and we print either vowel or consonant. Or it might be different, but we assume that if it's not vowel, it's consonant. It's unclear what will happen if we enter the dollar sign or space, but we assume the input is correct. So A, E, I are vowels, okay? They can be capitals or small letters, and X, Z, and B are consonant. So this is the problem. We again create a new class which will be called vowel or consonant. Okay, vowel. Okay, looks correct. I'll create my main method, the entrance for this program. I'll copy this scanner from another class I have already written today to save some time. And I will say something like string letter equals to scanner dot next. Do I have next char? I don't have, so I'll take the next one. Then it's good to have letter is equal to letter dot to lowercase. This means that capital letters will be turned to small letters. And now I can say something like switch, and I can say also that letter is letter. No, it's unclear what will happen when we write several letters together. For example, if we enter hello, because we are allowed to enter hello, we might take just the first letter, or the program will not work correctly. But we can say something like, if the letter is we can say like this: input, this is the input, but char letter equals to input dot char at 0 position, which means dot take the first. I don't have the first, but this is the first character. Okay, this is what we can do with strings, because this is string, but generally we can just take char at position 0. So this is the letter, and now the letter is a character. For example, it might be A, or it might be, for example, A, O, it might be also I, U, and what were the other consonant vowels? We can check in internet if we can't remember them. Vowels in English. Okay, so vowel letters are A, E, I, O, U. There are 5. I have forgotten the E. This E. Okay, I'm ready, and I'll print vowel because this is what is required from me with capital letter. Otherwise, I'll print consonant. And that's all. Let's check whether this runs correctly or not. I will enter A, it's vowel. I will enter S, is consonant. I will enter E, capital, vowel, and T, capital, consonant. And if I enter hello, it's consonant. If I enter apple, it's vowel, because it takes just the first letter, only this first letter. Whether this is correct or not, it's a matter of definition. But we can go ahead, and this is what I had in mind before the start of this lesson. I had prepared to take the char at position 0, because if we have a string like, for example, hello, we have this at position 0, this at position 1, etc. So each letter is numbered, which is natural. So we have the letter, and we can check for vowel or consonant, or we can say dot to lowercase like we did here, dot to lowercase, and this to lowercase will allow us to check just these letters instead of all the letters. Okay, and finally, in all other cases, when we don't have a vowel, we consider the input is consonant. Okay, the next problem is called product of 3 numbers. We need to calculate the sign of the product of 3 numbers. Not the product, but the sign. For example, if we have 3 multiplied by -5 multiplied by 2, this is in fact -30. So the sign is negative, right? And if we have 1 multiplied by 2 by 3, it is 6, and it is positive. And if we have 0 multiplied by 4.5 multiplied by 3, it's 0, and the sign is 0. Okay, we enter 3 floating point numbers, and we print positive, negative, or 0. We can do this by multiplying the numbers, or without multiplying the numbers, by considering that if we have odd number of negatives, the result will be negative. If we have one of the product 0, the number will be 0, and otherwise it will be positive. Okay, it's called product of 3 numbers. Okay, new Java class, product of 3 numbers. In this product of 3 numbers, I have the main, Control V. Oh no, I don't have the scanner in the clipboard, but now I have it. I have taken this from the other class, and now I'll read the numbers. double num1 equals to scanner.next. Next double num1 to 2 and 3, and I'll do something like this. Double product equals to num1 multiplied by product equals to num1 multiplied by num2 multiplied by num3, and if product is 0, print 0. Otherwise, I'll have as if it is positive, I'll print positive. It is less than 0, I'll print negative. Let me check whether this runs. 3, 4, 5, positive. 30, 0 minus 0.5, it's 0. Minus 0.5, 1.5, 3, it's negative. Minus 1, minus 1, minus 1, it's negative. And minus 1, 3, minus 1 is positive. Looks it works correctly, but this is the solution where we multiply the product. I'll have another solution, which is something like this. We can count the number of negative numbers. So int count of negatives is 0. If num1 is less than 0, then I will increase the count of negatives. Okay. I'll do the same for num2 and for num3. And now I know how many negative numbers I have. If they are odd number, the final product will be negative. But if we have 0, this is a special case. So if num1 is 0 or num2 is 0 or num3 is 0, then this is 0. Otherwise, if the count of negatives is odd number, which means %2 is 1, I'll print negative. I'll have, for example, minus 1, 5, 5. I have one negative number. So if I have 1 or 3 negative numbers, the result will be negative unless it is 0. Okay, and finally, it should be the last case, positive number. Positive. This is our second solution. This is our first solution. I have two separate solutions for the same problem. Okay, let's check whether these both solutions give the same result. 3, 4, 5, it's positive. Okay, I run this. What happens? Minus 2, 4, minus 2, positive. I have 3, 4, minus 2, negative. Minus 2, 3.5, 0, it's 0. Looks like they work, both solutions work correctly, so we are done with this problem. This is the solution I had in mind before the start of this lesson. It was about checking whether we have 0. If we have 0, if one of the input numbers is 0, the final product will be 0. Otherwise, we count the negatives, how many negative numbers we have among the input numbers, and if they are even, we have positive. Otherwise, we have negative product. That's all about this problem. So let's go ahead with the next problem. The next problem is called sorted numbers. The goal here is to write a program which checks whether a given series of numbers are sorted or not, are arranged in non-decreasing order or not. So we read three numbers and we print ascending if the numbers are in ascending order. We print descending if the numbers are in descending order, and not sorted in any other case. So 1, 2, 3 is ascending and 3, 1, 2 is not sorted. 1, 1, 2 is also ascending. This is because it's not well explained here that 1, 1, 2 is still ascending. So I believe that if we have A less than or equal B less than or equal C, this means that the sequence A, B, C is ascending. Okay, so that's all. We read three numbers and we do this. Oh, we already have this. I will copy paste this class, Control C, Control V. It will be called ascending numbers or sorted. Check for sorted numbers. This looks better. And I will take the first part here where I read these three numbers. So what I can do, I can check whether if num1 is less than or equal to num2, and in the same time num2 is less than or equal to num3. In math we can write like this, but in Java we can't, so we should do this, which is exactly the same. In this case I would write ascending. So for example, I have here 5, I have something bigger or equal than 5, for example again 5, and here I have 7, it's ascending. It is descending if I have num1 bigger than num2 and num2 bigger than num3. In fact, it might be ascending and descending in the same time if the values are 1, 1, 1, for example. But I assume that we should define this better. Strongly ascending or non-descending, right? And else, finally, I'll print not sorted. It depends on the definition whether it allows equality or not. I will consider the numbers are ascending if they are strongly ascending. For example, 5, 10, 20. 5, 5, 10, it's not sorted. But it's a matter of interpretation of the problem statement. Let's check whether this works or not. Okay, I'm waiting for the compilations. 10, 20, 30, it's ascending. If we have 30, 20, 1.5, it's descending. If we have 20, 30, 5, it's not sorted. Looks correct, so let's see the original solution we had. Oh, it's exactly the same, and it is strongly with this strongly ascending and strongly descending problem definition. Okay, we're done with this problem, so we can go ahead with the next one. The next one is called vacation expenses. It's about writing a program which calculates a vacation expenses. It reads season, accommodation type, and count of days, and prints the total expenses based on this table below. So, for example, if we have summer and we have camping, the rate per day is this 30. We don't have discount, so we have the count of days, for example 5 days, multiplied by 30, it would be 150. But if we have, for example, autumn and hotel, okay, the season is autumn, the accommodation type is hotel, the rate is 20, but we have 30% discount, so the rate is 20 by 0.7. Do you agree? It is 1.0 minus 30%. It's 70% of this 20 multiplied by the number of days. For example, it might be 5. So this is how this works. We don't have example here. Oh, it's a big mistake in this problem, but we should format the output up to 2 digits after the decimal point. Okay, so let's see here, vacation expenses. Okay, new Java class, vacation expenses. Again, I will need the main method. I will need the control tab, this scanner, control tab, control V, enter. Okay, and once I have the scanner, I can read from it the input. The input is the season string. Season equals to scanner dot next line. The next thing I read is the accommodation. It's with double M. And then I read the number of days. It would be int dot next int. It's days. So now I'll do something like, if the season is spring, it's better to have this dot to lowercase in order to be able to handle uppercase and lowercase. So I'll have now spring with small letters, and spring with capitals will also work. Okay, so if the season is spring, what we shall do? The season is spring. So if the hotel, if it is hotel, if accommodation is hotel, then maybe I will need a rate. In this case, the rate will be what? I have spring hotel 30, but with the 20% discount. 30 multiplied by 0.8. Otherwise, if it is camping, the rate will be 10 with the discount. This is for spring. In the same manner, we can handle with else if summer. Okay. In the summer, hotel 50, 30 without discount. It's 50 and 30 without any discount. Okay. Autumn, I can handle in the similar way. Autumn hotel 20, 15 and 30 discount. 30 discount means 0.7, 20, 15. 20, 15 with 30% discount. Finally, if it is winter, 40, 10. It's 40 with 10% discount it's something quite good. This, and 10 with 10% discount is this number. I may have this, and now I can print the rate, the double what I should expenses. I should calculate the expenses, their rate multiplied by the days, the number of days, and I need to print formatted with the second digits after the decimal point. So I need to print F, the percent to F, this with new line, this expenses. I can say something like, and let me check whether this works, because it's not very. This may be done with switch. Okay, I agree, but I don't like it. So let's run this, and we shall enter this. What will happen if we are in the spring at hotel for 7 days? 168 spring hotel. Spring hotel is 30. I'll run the calculator. So spring hotel is 30 multiplied by 7 days is this, but we have 20% discount, so by 0.8 it's 168.00. Works correct. Again, if we are, for example, autumn 15 days for 3 days, autumn at, sorry, I'll need to stop and restart. Autumn at camping for 3 days. Autumn camping for 3 days is 45 multiplied by 0. with 30%, it's 31.50. Looks like it's correct. The logic is correct. If I have mistake here at some of the numbers, okay, forgive me. But the logic here is correct, and it's a good example of nested ifs. 4 nested if statements, which handle these 4 basic cases and 4 inner cases, subcases. Okay, this is the solution I had in mind before the start of this lesson. I read the season, I read the accommodation, I read the number of days, and later, if it is spring, I check for hotel and calculate the total price, like this, days multiplied by the rate by discount. And later, if it is camping, I do similar calculation. I do the same for summer, for autumn, and for winter. And finally, I print the total price formatted as it is expected by the problem statement. Okay, let's go ahead with the next problem. It's called Cinema. It's about calculating the price for all tickets for a cinema movie. The program should read the type of the movie, the rows, and the seats per row in the cinema, and it should calculate all the price for all tickets. If all tickets are sold, what will be the price? So depending on the type of the ticket, the type of the projection of the entire movie, we have different prices. Premiere 12, normal 7.5, and discount tickets are 5. So this is price for one seat. So if you have normal 12 rows and 9 seats per row, we have this, we have normal 7.5, see, 7.5 7.5 multiplied by 12 multiplied by 9 multiplied by 12 multiplied by 9, it is 810.00, and the output should be formatted with 2 digits after the decimal point. So this is very similar, so I'll copy vacation expenses and this will be called cinema. So I read the type, rows and seats per row. I read type, rows, integer.parseInt of scanner next line, and seats per row. And if the type, I'll have two lowercase here, and if the projection is normal, okay, price per seat will be 7.50. So I'll have something like double price per seat or ticket price. Ticket price looks better. Ticket price will be 7.5 for normal, else for Premier it's 12.00, and otherwise it's normal, and the ticket price will be, no, it's discounted, it would be 5. Okay, so I have the ticket price, and if I have the ticket price, I can calculate the total price, which will be the ticket price multiplied by the number of rows multiplied by the seats per row. Again, by design we want to calculate how many, if all the tickets are sold, what will be the incomes. It will be something like total incomes are these incomes. Let's check whether this works correctly. This is the entire solution. I'm not sure whether this will work correctly, but let's see. Normal 12.9, normal 12.9, 810.00. Looks correct. And Premier 2030, 7,200. Looks correct, so we can go ahead. This is the solution I had in mind. I read the input data, I calculate the number of seats, and if the type is Premier, I print the seats multiplied by 10 and format it correctly. Again, if it is normal, I will print the seats multiplied by other price, and I just have to check these three cases: Premier, normal and discounted ticket, and to multiply by different number, which is the ticket price. So we are ready with the cinema problem, and we can go ahead with the number operations problem, which is about writing a problem to evaluate operations, which reads two real number and math operator from the console. Math operators are plus, minus, multiplication, division, and percent, which is the remainder of division. And to apply this operator with the given numbers. This is the example which explains the problem better. So if we have 10, 12, and plus, we need to calculate 10 plus 12. If we have 10, 12, and percent, we need to calculate 10%, 12. And this is the output. The first number goes here, the second number goes here, and the third number, and the result of first operator second goes here. Number 1 operator number 2 equals to the result, where the result is this, the operator this. Okay, so how to run this? We can just read the input and check. If the operator is plus, sum the numbers. If the operator is minus, calculate the subtraction. If the operator is plus, is multiplication, is the star, multiply, etc, etc, etc. So let's go ahead to solve this problem. It's called number operations looks correct. So I'll have the main method here, main method. I'll have the scanner here, Control C, Control V. I pressed Control Tab to go to the next window, or the previous window, Control Tab, and Control Tab back. I copy this line, Control C, Control Tab, Control V, and this is how I have the scanner in less time. Okay, so next I'll read the first number. Double num1 equals to scanner dot next double. Then I read the num2, and then I'll read, okay, n1 operator n2. I need to read here the operator scanner dot. By the way, I have a mistake here, but I will explain this later. This will not work, think why. But let's do something like if operator is plus, then print what we need, n1 % s, for example, %s, the operator %s equals %s, or this will work correctly. It's not explained at which format we should do this, so we can just do this, or maybe %f will work better. I'm not sure, but this should be num1 num2 num1 plus num2. Print f /n. I'm not sure about this, so I will run the program when still it is unfinished to check whether it works correctly. Okay, so I run number 1 5 operator plus. Oh, I have exception. It's hard to understand what's here, but the problem is that if we read next double, this next line will no longer work. So we should use next one and double dot parse. Sorry. So be careful when you mix reading numbers and reading strings. If you read strings, later you can read numbers. But if you read numbers, later you can't read strings. So you should either read only strings or do something else. But in this case, It's just the easier way is to read the first one, read the second one, read the third one, and parse this to double, parse this to string, parse this to double. Let's try again and see what happens. Okay, so if we have 5 plus 10, wow, 5 plus 10 is 15. No, 5 operator num2, 5 plus 10 equals 15. Let's try again. I fixed the bug. Okay, this problem looks a little bit more complex. 5 plus 10 is... oh, it's not 40 point, it's string here. This operator plus cannot be floating point. Let's try again. 5 plus 10 equals 15. Oh, %s looks better. Let me try, because this adds some decimal part. Okay, let's try again. 5 plus 10 is 15. This is how this works. Because the floating point numbers are always printed like this with 0.0. This is how this works. If we want to achieve 10 plus 12 is 22, we should format the output without this 0.0, which should be %.0f. It should be something like this. 5 plus 10 is 15. But if this is 5.5 plus 10, it's 6. So it's better to leave this %s and just to have 0.0, which is not a problem. 5 plus 10 is 15. Okay, we managed to put this correctly, so I can check for minus, and this will be minus here. Plus minus, multiplication, the star will be multiplication. I have also division, and I have also percentage. And let's run this. 5 divided by 2, %2 is 1. Okay, but 5 divided by 2 is 2.5. And 5 multiplied by 10 is 50. Looks correctly, so I assume we are done with this problem. And it's not very short, but that's life. So let's go ahead with the solution I had in mind before the start of the... oh, but the operation is last. 10, 12, 10 plus is last. Okay, we can change the order. Here, if we have plus, we calculate the result. If we have minus, we calculate the result, etc. And finally, we print number 1, operation, number 2, result. This works even better. Yeah, this works better because we have only one plus. Let me try. Double result is 0. Result equals to num1 plus num2. Otherwise, result is num1 minus num2. Here I have result equals to num1 multiplied by num2. Here I have the result as num1 divided by num2. And finally here I have result equals to num1 percent num2 result, and after that I print the result. Looks better, more clean code, like 5 multiplied by 12 is 60. Looks correct. So let's go ahead with the next problem. The next problem is called ATM, Automated Teller Machine, or the cash machine on the streets. It's about writing a problem which simulates an ATM withdrawal. So we have balance, withdraw request, and limit. For example, we may have balance of $500, we may want to withdraw $50, and we have limit of $100 per day, for example, or per operation. And we print the withdrawal was successful if the balance is enough and the withdrawal is within the limits. We print the daily limit was exceeded if the limit is exceeded, and we print insufficient availability if the balance isn't enough. Exactly in this order, because sometimes we might have several errors in the same time. Because yeah, but we should print one of these three messages. First we check this. If it is not, we check this. If it is not, we check this. This should not be daily limit, this should be just limit. But this is an example. We have 420 balance, we withdraw trade $20, we have limit 25. The withdrawal is less than the limit, everything is successful. We have 10 balance, we have $50 requested and limit 20. So the limit is less than the requested, and also the availability is also not enough. But we print only the first error message, and later we print the others. So if we have multiple errors, we print only one error message. This is by design the problem statement. So I'll create a class called ATM with the main method main. I'll press Ctrl Tab to go at this the previous problem solution. I'll press Ctrl C, copy, Ctrl Tab to go back, Ctrl V, which is paste, copy paste. Okay, so I have the scanner. I don't like to write it, it will take more time. So now I will need to read the input data, balance, withdraw, limit. So I have double balance equals to scanner dot next double. I'll copy this 3 times. Balance, withdraw, complex word, and limit. So the first case, if I have enough balance is bigger or than the withdrawal amount. I have enough balance and the withdrawal request is less than or equal by the limit. In this case, everything is okay, and I will print the withdrawal was successful. This message. Otherwise, if I will check for the limit. If the limit is, if the withdrawal is bigger than the limit, I will print this. I try to withdraw more money than the limit. This is. And finally, if it happens that insufficient availability, if I try to withdraw more money than the availability, than the balance, S out, okay, this is insufficient availability. Let's try to check whether this works correctly. 420, Control V, it doesn't work. I'll try to copy this, to run this, and paste. Oh, it's pause, it's not paste. Control V. Withdrawal is successful. Okay. 10, 50, 20, Control V. Limit was exceeded. And if I have 500 and I want to withdraw 600 and I have very big limit, the availability will not be sufficient. So this is the entire problem solution, and we can go ahead with the solution I had in mind, which should be very similar. Read the number, check whether the balance is enough and the limit is okay, and we print the withdrawal was successful. If the limit is reached, we print the limit was exceeded. It's not daily. I changed this because it's not correct to be daily. It's a per operation limit. Sorry. And finally, insufficient. Yes, because in all other cases it will be, we should fall in one of these three cases. Either we have successful withdrawal, or we have limit exceeded, or we have insufficient availability. Yes, we don't need to put this, but it's better to have it. The code will be more readable. So we are done with this ATM solution, and we have our next problem to be solved. It's about writing a problem to find the biggest among 5 numbers. We have 5 numbers, 5 integers, and print the biggest of them. Here is 5, here is -1. Okay, so let's solve this problem. It's called biggest of 5 numbers. We go here, we increase the font with Control and the mouse wheel. I print main method. I press Control Tab to copy this. Control C, Control Tab, Control V, Enter. And now I read the first number, int num1 equals to scanner dot next int. Okay, and I copy this 5 times. 1, 2, 3, 4, 5. And now, when number 1 is the biggest, if number 1 is bigger by the number 2 and is bigger than the number 3, and num1 is bigger than num4, and num1 is bigger by num5. In this case, okay, the biggest, what I should print? I should print just the number. The biggest number is num1. Do you agree? Num1 is bigger by num2, by this, bigger than this, bigger than this, bigger than this. So it's bigger by all of the others. I print it. But it should be bigger or equal, because if it's equal to some of the others, it's still the biggest, right? If we have, for example, here 5, 5, 3, 5, 3, we agree that num1 is the biggest, and it's equal to this one. Okay. Otherwise, I'll have another check to check whether number 2 is bigger than number 1, 3, 4, and 5. Maybe I need to reduce the font. This is number 2 is bigger than 1, 3, 4, 5. Then number 3. It should be bigger than num1, num2, 4, and 5. Num3 is bigger than 1, 2, 4, and 5. The same for number 4, sorry. 4 with 3 and 4 with 5. So number 4 is bigger than 1 by 2 by 3 and by 5. It should not be bigger than itself. And in all other cases, it should be number 5. Because if we have 5 numbers, definitely one of them is the biggest. Or we may have several biggest ones, but one of them will be bigger or equal than the others. So if it is not this, 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 it should be this. Right? Let's see whether this works or not. So I have, for example, 10, 1000, 20, 30, 40. It's 1000. If I have 5000, 1, 2, 3, 4, it's this. If I have 3, 4, 1000, 5, 6, it's 1000. The third, 1, 2, 3, 1000 is the fourth. Works correctly. I have 3, 4, and 1000. So I matched the five cases. I had the first biggest, I had the second number to be the biggest, I had a test where the third was biggest, the fourth, and now in this test the last one is the biggest. I can try with negative numbers, minus 10, minus 25, minus 15, minus 30, minus 5. Minus 5 is the biggest. Looks correct, so this is my solution and it's correct. Let's see what I had in mind before the start of this lesson. It was very similar. If number 1 is bigger than all the others, so it's bigger than num2, in the same time bigger than num3, in the same time bigger than num4, and in the same time bigger than num5, it's the biggest. In the same time, else if, check the same for num2, check the same for num3, check the same for num4, and otherwise num5 is biggest. I already demonstrated this to you, so we are done with this problem, and I'm happy that this was the last problem in these exercises. And in summary, we demonstrated and explained that an if-else statements can be nested within another if-else statements, which is natural. If we have if-else is a statement, it can be put everywhere where a statement can be put. Everywhere where we can put system out println something, we can put if-else. If in the else statement we put another if-else, it's a statement, we can do it. So we can nest statement if-else inside another if-else. So we can have if-else, if-else, if-else sequence, and in some of these cases we may have other if-else, if-else, if-else sequence, like we already demonstrated. Combined with the and, or, and not, and brackets, with these logical operators, we can achieve more complex conditional statements, and we can check whether num1 is bigger than several other values with the AND, or we can construct more complex expressions. Together with the nested ifs, we can check almost everything. And the switch case statement, it's alternative to the if else, where we have a single expression and we check it for many values. It's very useful with multiple labels, where we can check for many values and do the same thing to avoid something or something or something or something. So in summary, we already have the knowledge and skills about building complex programming logic, branching logic, which does different things depending on the different input by checking with logical operators and with more complex conditional statements. Now we have good knowledge and skills about using conditional statements in Java. In the next lesson, I will show you how to repeat pieces of code using loops, and this will be our next level of advancement in the coding skills.